I always forget the. As always, I always forget the this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot.
Now you can actually hear me. Oh, that was probably very loud. I was doing a mime thing.
This dot, this dot. I'm gonna do this dot, this dot.
Do you think I could do an entire mime coding train episode? Okay, I gotta talk about this bow tie that I'm wearing, which I didn't realize I'd have a wardrobe malfunction with this microphone. Okay. How are we doing here?
This dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody composed that song for me.
You know, it wasn't really a coding train episode this morning because I didn't read from our coding train storybook. I forgot that I opened with our coding train storybook. Oh no, this is not our storybook. Well, this would be interesting to do a dramatic reading from. Let's try that. Suppose you're using simple search to look for a person in the phone book. You know that simple search takes ON time to run, which means in the worst case, you'll have to look through every single entry in your phone book. 16,704. 158. That's it. Just 158. No thousand, no tens of thousands, just 158. 39,842. 9,802. 47,463. I have a limited amount of time, so I think I'll move on from now. Song is too loud. Okay, that's useful to know. Okay, so this is the coding train attempt number 2. This morning I had a little bit of a failed live episode where fire alarm went off, not actually in this building, but in the building next door. But it was so loud, I thought it was this building, and I had to leave. But this is a weekly, sometimes less than weekly, sometimes more than weekly live stream where I, Daniel Schiffman, entertain you, possibly not in an entertaining fashion at all, with making coding tutorials and little code examples and that sort of thing. So I don't know what's going on in the chat, but I will choose to ignore it. So by the way, first of all, let me do a little plug here. Coding Train brought to you by Ginger Tea. One of the most frequent comments I get in my YouTube comments is, what's this guy on? Or I'll have what he's having, or whoa, what's variations of those types of things. So I thought I would reveal on this very episode the contents of what I'm on. And it is, okay, hold on. And it is, I have to reply to a text message in a second. It is ginger tea. I like this ginger tea, which is Nature Boutique London, natureboutique.co.uk. Oh, this is like, am I buzz marketing some like random tea company's tea? I did not mean to do that. This, by the way, this is all just product placement. Today's product placement. I'm wearing a bow tie. We'll get to that in a second. Yogi ginger supports digestion. This has in it, by the way, people think I look younger than I am, but now you can tell, which is very nice of you, thank you. I don't think that I do, but you can tell that I'm not because I take my glasses off to read this. Ginger root, organic lemongrass, organic licorice root, organic peppermint leaf, and organic black pepper. Now, that music, which was too loud, I'm going to play it for you again. This dot song.
I always forget the this dot.
I have to reply to a text message.
I'm going to do this dot, this dot. I'm going to do this
important.
Dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot, this dot.
Okay.
This dot.
That was important because that's related to my schedule today, and it might, the fact that I replied to that might allow me a little extra time to live stream. Okay, what else? Okay, so I want to start, okay, so you might be wondering, he's on Wikipedia. I'm on Wikipedia. Yes, folks, Daniel Schiffman, have arrived. I am on Wikipedia. Thank you, thank you. Where's my applause thing? I gotta really work on these sound effects. Someday. Now this bow tie, I want to mention this bow tie. This is from an alum of a program where I teach called ITP. It is a Kickstarter project. It is DIY light up paper bow ties. Can you see that this bow tie is lighting up? It's a cool little DIY electronics project, and it's fun for makers of all skill levels. So if you're interested, you can go to bit.ly bow ties are cool ITP. Let's go there now and see if that takes me to the right place. Bit.ly bow ties are cool ITP. This work? There we go. So check out this DIY light up paper bow ties on Kickstarter. Product placement. This is an experiment that I'm trying. I'm just doing this because Natasha's great. This is a wonderful project, and she gave me some bow ties. So, you know, I'll wear whatever people send me to a point, clearly. I don't know if you can tell, though, it's blinking. I didn't actually put this together. She put it together, but there's a nice little video how to put it together. So check it out. Okay. Oh, make your own neural network for only $0 on Kindle Unlimited. This is a book I was talking about earlier today. Okay, where are we? I am going to do my segment called Work from the Community. Now, one thing I like to try to do. Let me click back over here to this live chat. One thing I like to try to do is show things that people are making that are sometimes just their own projects or variations off of things that I have done on a previous coding challenge. Again, I don't have a particularly great system of getting submissions. You can always do, let's actually look, what's one of them? Let's look at Unikitty. See if anybody made a Unikitty variation. I don't think they did. But if I go to, not Rainbow Topics, if I go to the repository that has all of the source code for my videos, and I go to challenges, and I go down, and under Unikitty here, now there is no README file in here. Let's find one where there is one. Fractal spirograph. Let's try this fractal spirograph. There you go. So if you made a project and you want to submit it, you can, now this requires a little bit of knowledge of GitHub. If you don't know how to do this, I do have some GitHub tutorials that you can watch, or I'm happy to kind of help people along somehow, or just file a GitHub issue to say, hey, I need help submitting my thing, and someone will hopefully jump in and help you. But you can see, one way you can do is find the project that it relates to, add to the README file that's there, or create a README file if there isn't one already. And I'll try to also get projects that way. Currently, my system is I have a Patreon, which is a crowdfunding thing, and so I ask people who are in that patron group to submit stuff, and that's what I have for you today. So I'm going to start with Ada Lovecraft's CodePen. And I'm going to change the view to full page. And then I got to go over here, hold on, and just make sure, let me see here. And find any information that Ada might have sent me about it. So this is her CodePen. It is, ooh, look at this. This is just beautiful. So I have a suspicion. It's called Smoke. I saw the word noise in there somewhere. So this looks like a really nice variation of some of my, I don't know if it's based on, but this is a project that builds off of a lot of the Perl and noise stuff that I've done. There's a lot of information that Ada sent to me about this project. Generates a noise map as opposed to calculating noise for hundreds of particles. So instead of having particles, one of my examples has particles move through a field of noise. Oh, can I just please start over? Get to it already. I'm getting to it. Hello, Ireland. Isn't it St. Patrick's Day today, by the way? I guess I should have worn a green bow tie. And so each particle is represented, let's see, it's like a mouse is on the dance floor, which is very exciting. And it turns and makes various motions based on colors. And so these are the rules that the mouse will follow. And each turn between negative 99 degrees based on the amount of each color. And so, there's all these tiles underneath that are full of color, and these particles turn and move according to those color. I didn't read, there's a much more elaborate set of rules there. I just didn't read the whole thing. But thank you, Ada, for submitting this wonderful project. I encourage those of you who are interested, I will include links to her code pen if you check out this video's description after it gets published. Okay, moving along. I really don't do a good job of this. Let's go to this next link. Oh yeah, okay, so hold on. Let me find the information about it. This is a simulation demonstrating the concept of element half-life for high school chemistry students. Oh my goodness, science. Amazing. Okay, so let's see, there's 1,000 particles. So I can change the number of particles. That's cool with a little slider here. Then I can hit decay, and we can watch the elements decay based on half-life. Ooh, it's unstable. So I can change to element Y, maybe, no. And I can try decaying again. Emitting radiation, whoa, unstable. I love this. So first of all, science is awesome. I wish I was wearing my Rogue NASA shirt. I didn't even do my product placement for my coding train shirts, but whatever. This is great. I love these kind of animated systems. I can hit reset up here. I can change to element Y. Oh, this is really, really great. So I don't know enough about the science here. I have my own sort of general memories are coming back into me, cultural sensibility of elements and half-life. But this, to me, I can imagine is a really great use of interactive programming to create simulations of things that people can use in a science class. So I hope this helps somebody. Okay, let's keep going here. I'm going to go now to this next one, which is a code pen from Alka. Oh yeah, this is great. Grungy retro text and CRT effect. It's a glitchy, corrupted, grungy retro text and CRT effect. I just said that. So it uses cycling effects to kind of have this old style X-Files, CRT monitor. So what's great about this, if you look at it, is that this is not a pixel by pixel process. I believe it's actually using text and a font rendering. So I know Alka has another version of this that takes like a Twitch chat and just renders it this way. It's great to see. Great work. Also, now this is from Robin Lefebvre. Okay, I got a game I gotta play. So let's see if we can figure this out. Use left-right arrows to change the ball's color. Be the same color as the obstacles you collide to. Okay, so, I want to be green? Oh no, wait, hold on, click in here. No, I need to be red. Red. I did it. Oh, I need to be blue. No, green. Blue. No, blue is good. Blue. Oh, I missed it. Oh, but it's yellow again anyway. Yellow. It looks like this is using a sine wave pattern. You know, this kind of reminds me of a game of like sort of having to learn to type, where I've got to kind of press the right keys in the right sequence as words are coming out at me. We should try that to see how fast I type to make a game like that. This is great. Beware, balls feels friction and will become slower over time. This is interesting. So any of you interested in playing this, I encourage you to check out Robin's code pen. And to me, it feels a little strange sometimes that I get the same color twice in a row, although I guess that's kind of a good thing. I guess that what I might like for this is actually a very simple training level and also some feedback. So I think I would love visual feedback if, as the ball crosses the correct or incorrect color, I kind of hear or see something. And one thing I was kind of confused, if I hit to the right again, I wrap around versus whether I don't. So I think there's like a little bits of interaction design that could probably be cleaned up here, but great idea, fun game for a fun game. Okay, and now we are going to, the double pendulum. Oh my goodness. So this is something I really want to do a coding challenge on. This is an animation of a double pendulum using differential equations. I have a bunch of different pendulum examples already that I made for Nature of Code, and what's really interesting about this is what it is. Instead of just taking one single pendulum, if you take one swinging pendulum and attach another one swinging to it, the sort of chaotic, unpredictable, complex, beautiful paths that these two pendulums attached to each other make are quite amazing and interesting to see. So it would be great to encourage anybody to to Google double pendulum, to look at algorithms, to take a look at this example, I would love to come back and do this as a coding challenge sometime. And now we have, okay, so this comes from Mr. Muse. And I'm really excited to show this to you. It's just a paste bin, but I think I already opened it in processing. So this is based on my A-star coding challenge. And what it seems to do here is so it generates using Perl and noise. This has a lot of things. This is generates with Perl and noise a terrain. Okay, so Perl and noise, you have these smooth random numbers over a dimensional space. So these are, you can imagine each pixel being random, a random color, a blue, a shade of green, and they're similar to the ones next to each other, and maybe there's sort of like a thresholding that if the noise value ever goes above a certain amount, it changes to blue, and you get these kind of lakes, this terrain-like quality. Now, I believe what happens now is if I were to click, like, let's say I want to get from here, and then I want to get to here. Well, let's just put it over here, make it simple. It's now, suddenly it changed into 3D, which is kind of interesting. It's now using A-star, the A-star pathfinding algorithm, which I have a coding challenge and example about, to find the path from beginning to end. This is perfect, actually, because this really relates to this thing I was talking about this morning, related to artificial intelligence, this idea of creating the illusion of intelligence, of agents that are moving around a computer graphics space, making intelligent decisions about how to move. And so this is a sort of perfect application of that. I guess I have the questions I have for this that I'd be curious to know about are, number one, what do we get with the 3D here? So I don't fully see the transition between, I guess I'm seeing the full map and then kind of like a zoomed in version of it. And maybe there's, the color relates to 3D and can you go over or not over certain things? So I'm a little unclear on the 3D aspect. And then the other thing I'm curious about to wonder is, can the path go anywhere except for water? Is that what's going on here? So what are the rules that are defining how the path should go? Okay, I'm going to go back to my chat. So great work, everybody. Thank you for sharing all these projects. I hope that people enjoy seeing them. If you're interested in more, I need a way of people to like have a discussion or give feedback. I guess you could do that in the chat and that sort of thing. But now I'm going to move on to today's business. And I'm going to stick around here in processing and make a new sketch. And so I've been having, you know what I need to do though? So I've been having a little bit of a rough week here. No need to feel sympathy for me or anything. It was fine. And next week I'm embarking on a bunch of difficult things. So I wanted to do something today that was very beginner friendly. I also eventually want to look at different algorithms to train a computer to play certain games. And I've had requested a lot to do just code Pong as what I hope will be a very simple coding challenge. I also had a lot of people recently ask for me to bring back the timer. So actually, before I do Pong, let's make a JavaScript timer in P5.js, because I'm going to need a timer. And having a timer is probably a terrible idea, but we're going to do it anyway. So let me go here. Let me go to terminal. And I have no idea how I'm going to do this. I mean, I have some idea how I'm going to do this, but it's not like I've done this before. So, okay. So what I'm going to do is come over here. Let's close all these. That's fine. Close that too. Refresh. Localhost. Oops. Everybody relax. Computer, relax. Everything's fine. I forgot that I have some nonsense stuff that I don't need, like this. And I need to have the DOM library. Oops. Hold on, everybody. I want the sound library too. And I need my ding sound effect. Definitely need the ding sound effect. Ding.mp3. Here we go. Let's find that sound effect. And let's put that in here. Show in Finder. Okay. This sound effect. Can you guys hear that? Okay. It's cooked. I'm cooked. Okay. Here we go. So, how to get off track when you just said you're going to do a Pong challenge. So I'm going to make some, I want to do some simple stuff today. And I think this timer, I'm going to do this timer in P5.js without canvas. And here we go. So this is going to be the first coding challenge. Make a simple timer app. And I'm not going to think about style or design here. I'm just going to make it functional. And I'm going to make it flexible so that you can give a URL path with an amount of minutes, and then it does the timer for that many minutes. Ooh, that's exciting. Okay. Yes, Tushar, do something for beginners. This is relatively good for beginners. Okay, here we go. Hello, welcome to a coding challenge. In this coding challenge, I'm going to make a JavaScript timer using the JavaScript library P5.js. So what do I mean by a timer? What I want is on the screen, I want the thing that Chrome does. So if I just type in timer 5 minutes, or it's not Chrome, it's Google, whatever. Google does this. It gives me a little timer that counts down for 5 minutes. I want exactly this, but I want to make my own. Although I guess this works just fine. I want to make my own. Because I'm going to make my own, and you, why did I say Chrome when it's not, I mean, anyway. Time out. Leave this page. Okay. I'm going to do this again because today is the day where in my challenges, I am not allowed, if I have to debug, I have to debug. They take as long as they take. I will not, unless there is a big technical disaster where there's a fire or somebody knocks on the door, I'm not stopping in the middle. Here we go again. 5, 4, 3, 2, 1. Hello, it's a coding challenge. And this coding challenge, I'm going to do exactly that, but I'm going to program it. I am going to program a timer in JavaScript. I'm going to use the P5.js library for some of the elements that I'm going to put into the web page that will do the timer thing. But otherwise, it's just that. A little simple timer. This should be easy. It shouldn't take very long. And actually, the reason why I'm building this timer is because I'm going to do a coding challenge with a timer on, which I've done in the past but haven't in a while. So imagine a timer going on right now. Let's say this is going to take 15 minutes. Think we can do this in 15 minutes? Okay, so what's the functionality that I want? If you ever go to Google, which you probably do, did I plug Google? I didn't mean to plug Google. And if I type in timer 5 minutes, it knows what I'm going to type. That's how crazy it is. You can see I get a timer. So this is basically what I want to program. And if I can make this and make it easy for you to do the same thing, you could probably come up with a much more creative version of this or use this in some other kind of application that you're doing. Okay, so what do we need to get started? Let's leave this page. Let me go to my code here. So there's really nothing in my code but the setup function. And the setup function with the P5.js library is like the page is loaded function. So it's the place you can put all your code when it starts. But actually what I want to do before I do that is I want to add something to the page itself. So I'm just going to add a paragraph element and I'm going to put timer in it. And let's just do that for a second. And I am going to hit refresh, and you can see, look, there's that paragraph element there at the top. Now, I forgot there's some styling in here that I don't want, so there it is. I'm going to make it bigger. So you can see that's all I've got so far. But what I want to do is display the amount of time left in that paragraph element, and I'm going to do that with JavaScript. I'm going to control that paragraph through JavaScript. So to be able to access it, I need to give it an ID. Let's give it the ID timer. Again, I don't have to use the word timer, and really this should just say this, right? It's going to be a 5-minute timer to start, and then I'll show you how to set the amount of time that you want. Okay, so what should I do next? Let's leave it blank, or let's just put this in here so we see that there's something there. Hit refresh, there you go. Now I'm going to go into JavaScript, and first I'm going to say no canvas. Because P5 makes a canvas by default because there's a lot of animation stuff with P5. No canvas will get rid of that. And I'm going to say var timer equals select timer. So I want the select function is in P5 to access a particular HTML element that's on the page. In this case, I want that paragraph element. And I can set its content by saying timer.h, use the HTML function and say, this is where the timer will go. So if we see this and I hit refresh, you can see now I inserted that text from my JavaScript program there. Now, what do I actually want to put there? Well, let's start with putting 0. And now what I want to do is I want to every second, and I could do this less than a second, but my timer is only going to be in seconds. I want to every second increase this number. So I want it just to count seconds. Let's start as that first. Guess what? There's a function in JavaScript. This is not P5 now. This is a native JavaScript function called setInterval. And what I could do with setInterval is I could say time it 1,000. Now what does this do? SetInterval is saying, hey, I want a certain event to happen every so often. There's also setTimeout for I just want this event to happen once, but I want an event to happen every so often. I want it to happen every 1,000 milliseconds. 1,000 milliseconds is 1 second. There are 1,000 milliseconds, millis for thousand, in 1 second. So I want the event time it to happen every second. What is the event time it? Well, it's something that I have to make up. And what it is a function. So I can now write a function called timeIt, and this is saying, hey, this timeIt function should happen every second. Now there's some nuance to this, and there's another JavaScript function you could look into called request animation frame, which is sometimes something you want to use if you want to animate, and your animation might take a certain amount of time, and you don't want to wait. But setInterval is going to work just fine for this timer. And if we're like off by some nanoparsec a second, big deal. Okay, so what I'm going to do here is I'm going to have a global variable, and I'm going to call it counter. I'm going to set it equal to 0. And in timeIt, I'm going to say counter plus plus and timer.html counter. So what this is going to do is now it is going to every second increase the counter, and then update the DOM element. Okay, here we go. 0, 1, 2, 3, 4. Thank you. Okay, coding. Okay, anyway, so we get a timer and it's counting. Now here's the thing. I want it to count backwards. So I want it to count down to 0, not up, because I want a countdown timer. I mean, we could, and also when it gets to 60, I want it to say 1 minute and 0 seconds and not 61 seconds. These are two different problems. I don't know which to tackle first. Let's do the counting down. Why not? Okay, so let's say, okay, so what I need is I need a variable like lifespan or timer span. What's a good word for the amount of time left? Time left equals time left equals, let's just say 60. So what I want to do then, if time left is 60, what I want is to always update time left minus counter. This will work. This is an easy, right? Because I want to count down 60, 59. So when it's 60, 60 minus 0 is 60. When it's 1, 60 minus 1 is 59, etc. Okay, so now 60, 59, 58, 57. Hooray! Okay, so we're in good shape. However, let's make the time left now 65. How can I have it show the amount of minutes and seconds, not just the amount of seconds left? So here we go. Let's write a function. Let's just make this a separate function. And let's do convert, I don't know what to call this, convert seconds. So this function is going to get some amount of seconds into it. So I need to figure out, if I know the amount of seconds, how many minutes? Well, 60 seconds is 1 minute, 0 seconds. 61 seconds is 1 minute, 1 second. So there's a property here, right? I know the number of minutes. How do I know the number of minutes? If I say the number of seconds divided by 60, right? But here's the thing, I don't want to get a decimal result. Let me show you what I mean here, right? So if it's 120 divided by 60, that's 2 minutes. If it's 125 divided by 60, that's 2.083. So I could convert that into seconds, but I just want that number 2. And so what I can actually do is I can say floor. Floor is an operation to a number that takes off the decimal place. Even if it was 2.99999999999, I'm still going to get 2. So the number of minutes is floor seconds divided by 60. And then how many seconds do I have left? The number of seconds is what? So let's think about this. Remember how I just said, let's do a simpler example. 5 divided by 2 is what? 2.5. But another way of thinking of 5 divided by 2 is 2 remainder 1. The remainder, right, 122 divided by 60 is 2 remainder 2. That remainder is the number of seconds. So if, by the way, I've gone backwards in time. So all I need to do now is say, I can use the modulus operator. 122 modulus 60, 2. Modulus gives you the remainder of division. So that's the number of seconds left. So S modulus 60. So minutes is S divided by 60, get rid of the decimal. Seconds is S modulus 60, or divide the remainder of the division with 60. So now if I go here, and then I'm going to say return minutes plus a colon plus seconds. And there's some formatting stuff I probably want to do to this. So now I can say convert seconds. And I can add, so I'm just taking that number and passing it through this convert function that I just wrote. And now we have 1 minute and 5 seconds. And then 59 seconds. So there's some awkwardness there because I probably should use the same number of digits no matter what. So there's, I believe there's a number format function, I think in P5. NF-P5JS. Let's look at the reference. It's a function called NF, which is, let's look at this, number format. So number format is the number of digits to the left of the decimal and the number of digits to the right. So I can use number format to say I always want 2 digits. Oh, this is good. So I can say number format minutes 2. Number format seconds 2. And now if I do that and go back, there we go. Now let's change it to 5 minutes, which is 300 seconds. There we go. Now this is awkward because really if I want to have a timer, I probably want to say the number of minutes. And of course I might want to say the number of minutes and seconds, all that sort of stuff. But now I've got this timer. What I want to do actually, what I want to be able to do is just add something to the URL. So this might be something you may or may not be familiar with. You've probably seen this. You go to URLs all over webs and websites, and you see question mark, something equals something, ampersand, something equals something. These are what are known as URL query parameters. So what it's saying is this web page, when it runs, is going to get past this data. It's going to get past the number 5 associated with the variable, so to speak, it's key value pairs. The key is min for minutes, the number is 5. And I actually probably don't even, I could just do this, something simpler. I don't need to be so elaborate. But there's actually a thing in P5, query, how did I go back here? Query, URL params, yeah. So this is what I want, URL params. This function is a function that gives you those URL parameters dynamically. It's a P5 function that wraps all this sort of native JavaScript you would need to do this. So now what I can do is I can say var minute, so let me just say params equals, and what was the name of that function? Get URL params. And then I can say var minutes equals params dot minute. Let's just call it minute. And then I can say time left should equal what? Minutes times 60. There we go. So now if I go to here, okay, so what did I forget? So now if I go to here, now let's figure out what happens if I don't give it anything. So now I get this, because I didn't account for the case where I don't give it anything. So I should probably say, if params minute, like if that parameter exists, and I should also probably say if params, I should probably check to make sure it's a number. Oh, so much error checking. Oh, it's exhausting. Let's just do this for right now. So time left by default is going to be 300. Only if I give it something will I get something different. So we can see now, let's see what's going on here. Let's look at those parameters. Did I mess something up? Oh, do I have like an error somewhere? Oh, whoops, console log. What's going on? I've got a little debugging problem here. Oh, it worked. I don't know, it works. So it's 5 minutes if there are no parameters. Now, I don't have to change my code. Let's go in here and type question mark minute. Did I say minute or minutes? I don't remember. Minute equals 3. 3 minutes. All right, so you can see now I can make it minutes equals 50. 50-minute timer. So now I have a generic web page that any amount that I plug into it, it runs a timer. Now, if I say 65, it's not giving me 1 hour. So I'm going to leave this as an exercise for you, but let's at least make it ding when it gets to the end. Of course, now I can only make it a 1-minute timer. So let's leave it at 1 minute for a second. So I have a nice little sound here. I'm going to, it's a file in my folder called ding.mp3. And I am going to, when the timer is up, I am going to say, I'm going to add a function preload, which is a function for P5 where I can load media assets. And I'm going to say var ding equals load sound ding.mp3. And then what I'm going to do is I'm going to say here, when counter equals time left, yes. If counter, right, that's when it's over. If I start with 60 and the counter gets up to 60, if counter equals time left, then ding.play. But I also want to do some other things, right? I want to stop the timer from going. First of all, I could just have it start over again. Let's just do that for right now. I'm going to say counter goes back to 0. And let's just have counter go back to 0. So that'll be a nice way. So I could have the timer stop and I need a button for restart. It could do a lot of things, but I'm just going to play the sound and have the timer restart by going back to 0. And incidentally, or I could have it just completely stop. Let's also show you how to have it completely stop. So one thing I should show you here is, I'm just going to move this up here for my own eyes here, because set interval actually returns a value. And if you ever wanted to stop your set interval from continuing to go, you need to call a function called clear interval. So I'm going to say clear interval, and set the counter back to 0. Or I'm going to comment that out. So this should actually stop it. So let's just give it like a 10-second timer for testing when I don't pass in minutes. So now here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ta-da! There you go. JavaScript counter made with P5.js and some other stuff. There's so much you could do with this, so many features you could add, and things creative kind of twist on it, or maybe you just needed an interval for something. So I hope you enjoyed that coding challenge. As always, check this video's description, which will have a link to this code. If you use it or make your own variation of it, where you find that code, there might be a README file that you can add a link to your version of it to, all that sort of stuff. Thanks for watching, and I'll see you in the next coding challenge. All right, how long was that, by the way? A train whistle would be a better sound. I didn't record it. I'm looking at the chat. I see, whoops. All right, so that was good. Now that we have this timer, what I'm going to add to it actually is a button to tell it to start. No, I can just hit refresh. So what do you guys think? How much time should I give myself for Pong? And mind you, I have never actually programmed Pong. How hard could it be, right? And also, I tend to talk a lot and explain things more than I might. So how much time should I give myself? What people are saying didn't hear, did my ding not show up? 30 minutes. 40 minutes. No, I'm not doing more than 30 minutes. 15 minutes, I see. 20 minutes. I think 30 minutes is good. Maybe I'll be done early. It just wasn't very loud. The ding wasn't very loud. Probably have this down quite a bit. Maybe Mathieu, we can add a louder ding in post-production. Pong is 15 minutes. 4 days. So the other thing, let's try doing 15 minutes. Let's do 20 minutes because I'll spend 5 minutes. You know what I'm going to do? I'm going to allow myself to use the whiteboard for a few minutes at the beginning, and then I'll set the timer going, and we'll do it for 15 minutes. So here's the other thing I want to do. I want this to be very beginner friendly. So I think I'm going to do this without any object-oriented programming. So I'm just going to have variables for all the different pieces. And I was going to do it in processing. Yeah, people should have a betting. Definitely take bets. Hopefully not for any actual real money that's going to cause anybody a problem. So what do you guys think about that? I think I'm going to do this to make it really beginner friendly without any object-oriented programming, and then maybe I'll make an object-oriented programming version of it. I could even do that as a second part. And I kind of wanted to do this in processing just because it's such a standalone environment and people don't have to know. I mean, I could also just do this in CodePen. I always find that it's a little tricky for me to use CodePen on the channel. Okay. Make it OOP in process. People are liking processing, great. Bob, beginner friendly. I mean, please do blah, 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 blah. Whoa, for beginner, make it OOP. Well, it still would be, yeah. Nothing but variables does not make it beginner friendly. That's kind of, the thing that's tricky is to reuse the paddle object. Actually, not really. Not really at all, actually. Maybe I'll make objects. Okay. OOP and processing. Okay. All right. This is such an unscientific poll. I'm just watching the... Of course, beginners should learn OOP. I mean, the comment was written in the chat, beginners should learn OOP. Yes, I am a firm teaching programming. I get to OOP very, very soon. I was wondering... Yeah, so that's fine. That's fine. Let's because even doing it with variables, yeah, that's fine. I'll do OOP. People are, yeah. Objects are not efficient in this project. Oh my God, I'm getting too many comments. I can't decide. I have to stop looking at the chat. Everybody's telling me something different. I knew I shouldn't have asked. I have an idea. You guys will just all have to bear with me here. Okay, so we're going to open up Chrome. And we are going to get rid of this. Put this over here. This will live over here. That's my timer. And minute equals, we said 15? I haven't started yet, but just seeing that the timer works. Functional programming. Okay. Oh, good. There's a wonderful, actually, let me tweet this. I'm going to make a Twitter poll. I'm at Twitter/Schiffman. You can't see me doing this. I'm doing this on a separate computer. Tweet, how long will it take me to program Pong in processing? YouTube.com/Schiffman/live. And then I make it a poll. 10 minutes. What were your options? 10 minutes, 0 to 10, 0 to 10, 11 to 20, I'm going to say 0 to 15, 0 to 14, because if it takes, that's fine, 0 to 15, 15 to 30, 30 to 45, over an hour. Poll length, fine, I can leave that. Let's just make this poll length 2 hours. Or 1 hour. Okay, so I now just tweeted, if you go to twitter.com/Schiffman, I can pull up the poll. I should just be logged into my account on this computer. That way you could see my Twitter stream. I should have done this from the Coding Train Twitter account. Let's see if anybody, right now, people are guessing 15 to 30. I'm going to let this, I'm going to do this in processing. Oh, and I mentioned the wrong processing. Oh well, it's processing org. That was my mistake, but I don't want to delete this poll now. Okay. I'm happy to, how about I do it in both? Processing and P5. I'll do processing first, P5 second. I'll get it right the second time. Okay. How's this bow tie doing? Okay, here we go. Because I have a crazy idea of how I want to do this in JavaScript. I'll always happily make a P5 version of the same thing. So you'll never be lacking for the code. Okay. So let me just. Okay. So now I'm just going to add setup and draw. And I'm going to make a canvas size of 600 by 400, which kind of fits nicely over here. Okay, so this is all I have. Then I have to come over here and hit refresh when it's time to start. 15, I probably should give myself 20 minutes. Am I going to add a score, timer, an amount of time, sound? There's a lot of problems if I'm going to. Let's at least give me a sound file. The ding sound file is the only one I have. Reveal, show in Finder, ding. Okay. Okay, I got to get started here. Right? 20 minutes. Oh, wait. Oh, it says 15 there. Okay. Okay. I would love, to be honest with you, it does help my channel a lot, just from a pure channel marketing point of view. If I successfully have a 10-minute video that I make all of Pong in 10 minutes, people will watch that. Now, whether that's good for the core audience or for teaching or what, I don't know. But the videos that get watched the most are my snake game, and the purple rain one, both of which are quite short coding challenges. Okay. Oh, could you please put what you're coding in the title or description? It's very confusing coming in the middle of one of your live streams. That is a very, very good suggestion. I hope somebody can help me figure out how to do that effectively. I guess I can edit the description while I'm going. So let me, I think that's a good suggestion. It's just not really part of my workflow. Okay, here we go. I'm going to start this video, oops, from over here. It's crazy. Let me press. Bring back the mug. Oh, I'm in the wrong camera. Did you know that I have toy trains here with me? Maybe these I could juggle. Yeah, this is pretty good. Okay, I'm going to start this coding challenge from over here, which is nuts. Nuts, I tell you. What are we, 3 o'clock? Okay, I'm going to have to go soon, but here we go. Not looking at the chat or anything right now. My phone is like buzzing like crazy. Let me go look at that Twitter poll real quick. Oh yeah, people are really in the 15 to 30 range. Okay. Okay. Oh, you can't see me anymore. Okay. Hello! Welcome to a coding challenge. I am super excited for this one. It's been a while. People have asked me to do more coding challenges with a timer or simple games, and I'm going to program in this coding challenge Pong in 2 minutes and 30 seconds. No, definitely not. It's probably going to be like 3 hours. But you can see how long this video is, and then you'll know about how long it takes. I'm not stopping in the middle of this. It doesn't matter what bugs or things I can't figure out. I am going on. But I'm not starting my timer just yet. What I'm going to do before I start a timer is let's at least together, you and me, map out the pieces of Pong. Figure out what features we're going to implement. So if I have a computer graphics window, a canvas in a browser or some other kind of graphics window, what I need to have are 2 paddles. I need a left paddle and a right paddle. And then I also need to have a puck. The paddles move up or down based on keyboard input. So maybe like we'll do, I'm gonna look over at a keyboard, like, you know, A and Z and K and M or something, you know, whatever. So it could be played on one keyboard. I mean, obviously, one of the reasons I'm doing this is later I might make a video to look at some different artificial intelligence algorithms that might allow us to like see if we can have the computer play one of the paddles, but that's an aside. So I need the puck, and the puck needs to have an X and a Y, and it also needs an X, I'll call it X speed, and a Y speed, because it needs to figure out which way it's going. I need to have some type of collision detection between the paddle and the puck, and then I also need to figure out if the puck goes past either side, there's a score. So this player gets, you know, +1 score if the puck goes past the opposite side. It's like air hockey. It's Pong. Okay. Are we ready to do this now? Here's the thing. Have you ever programmed before? If not, you might have a little trouble following this video. But I'm going to try to keep this fairly beginner friendly. I'm going to use a programming environment called processing. You can learn more about processing in this video's description. And I'm going to use a concept called object-oriented programming, meaning I'm going to think of the puck as an object and each paddle as an object. And the puck is going to have data associated with it, like its location and its speed, where it's moving. And there's going to be functions like, does the puck hit the paddle? So those are the things I'm going to add to the program. I will also make a JavaScript version that you can run in the browser, so you can look in this video's description for that code as well. I'm trying to say all this stuff out now because I know I have to get started in a second. What else am I forgetting? I think I can just get going now. Okay, I'm going to walk over here. That's where my computer is. All right, now I have this timer going up there. It says 14 minutes. Oops, I'm in the wrong program. Here we go. This is processing. It's got a setup and a draw function. I haven't started yet. Don't look at the timer yet. I'm going to hit refresh. It'll go back to 20 minutes. I'm procrastinating. I'm going to do this. How long is this? It's already like 5 minutes long, probably. Let's just get started. Okay, ready? Here we go. 1, 2, 3. Okay, Pong. All right. Oh no, I'm panicking. Okay, first let me just add a background. I'm gonna make a background that is black. The puck is I want the puck to be, I'm just gonna make it a circle because that'll be easier to deal with. So let's just get started. Oh, and let me save this. Save Pong. I'm gonna add another tab here in processing, and I'm gonna call that puck. And the way object-oriented programming works is I create something called a class. And a class is a template for making things. So this is the puck template. I need to make an actual puck. So the template is going to have an X, and it'll start in the middle of the window. And the template, the puck, is also going to have a Y, and it will start also in the middle of the window. And it's going to have a function. I'm going to call it show. And I'm going to, in that function, I'm going to say fill 255 ellipse X, Y, and I'm just going to give it some arbitrary size, 24, 24. So the ellipse function draws a circle with, and how's the font size? Is the font size okay? Can you see it? Okay, so let's now go and run this. Oh, well, now let's make a puck. So now I can say puck, puck, puck equals new puck, and puck dot show. Is that the right thing? Is it called a puck? I don't know what it's called. Here we go. Ta-da! Am I done yet? No. So now we need that thing to move. So for it to move, I'm going to give it, I probably shouldn't. No, I'm going to say x speed equals, I'm going to make this a random number. So I can use the random function. I'm going to say random -3, 3. There's a lot of things about this that I should be using vectors for. And y speed is -3, 3. Here's the problem. I don't actually want to do this. Oh, it's so sad. But let's just leave it this way. I can improve this later. I don't like this because I could get a puck that's not moving at all. Let's just give it a fixed. Let's just give it a fixed speed, 3, 1. It's always going to move the same way. I'll fix that later. Void update. I'll call this. I'm going to write a function called update, and in update I say x equals x plus x speed. Y equals y plus y speed. Okay, so now if I run this, it doesn't do anything, but if I say puck.update, now I'm calling that function. Draw, by the way, is the thing that happens over and over again. Update show, background update show, background update show, background update show. I should not be singing, it takes up too much time. There we go. There we go. So now, oh, we're going to need some paddles. I strangely want to do something that I wouldn't normally do, but before I do the paddles, let's implement some other parts of the game. So let's write a function that's called edges. So really we have to worry what happens if the puck hits the top or the bottom, right? So if y is less than 0, then I need to reverse the y speed. So y speed times equals -1. And actually I'm going to do this if y is less than 0, and this, by the way, is a symbol in programming for or, in Java programming or processing, also JavaScript, 2 of these pipe symbols. Or, if it's less than 0, meaning it's above the window, or greater than height, meaning it's below the window. Reverse the speed. And let's be sure that this is doing that by kind of giving it a very kind of initial, oops, wrong thing, wrong. Let's just test this by saying, giving it a very slow x, but a fast y. That didn't work. Oh, I have to call it. So I have to say puck.edges. So I can write a function that gives it some logic to follow, but if I don't call the function, it doesn't do anything. So okay, so that's working. It's going to bounce off the top of the bottom. It does that in Pong, right? I think it does. Okay, great. So now let me go back to something more reasonable. So now I also want to check, though, if x ever gets past the window, then what I want to do is I want to say, I want to like reset the puck. If x is greater than with or x is less than 0. I want to reset the puck. Now here's the thing. I need to track both of those separately because different players are going to win, but let's just make that 2 separate if statements for later, but let's just call reset right now. And reset, so reset is going to be a function that I'm putting inside this object. And what does it do? It sets the puck back to the center. And you know what I'm going to do? I'm not even going to change it's y speed or x speed. I'm just going to let it be the same, which is I should probably have. So now we can see here's what it's doing. If it gets past the right-hand side, okay, so that's actually a problem because it's always going to go the same way. But okay, so we've got the puck moving. Yeah, I didn't. James in the chat writes, you didn't take into account the ellipse size, so it's going to clip on the edges, but not a big deal. This is a good point. I don't know if I have time for these details, but let me see if I can. I'll add that in later, perhaps, or that's something that somebody watching could add. Okay, we need some paddles. So what I'm going to do now is I'm going to make an object called paddle. And again, I need a template for the paddle. And the paddle is going to get, it needs to have an x location and a y location. And let's think of a height. And you know what? Let's use, and a width. This is a little tricky. I kind of want the paddle to be maybe using the reference point. Well, we're going to do what we're going to do. Okay. X and Y. Why is my, okay, stop. Everything's buzzing. Okay. I turn off notifications before you start these things. Okay. So the other thing I'm going to do is when I make the paddle, I want to pass in a, and I'm going to call this like, I'm going to say x underscore. This is a little bit weird if you haven't done object-oriented programming with construct. This is what's known as a constructor function. So y, so first of all, y is always going to be, yeah, let's have, okay, so here's the thing. I need a minute. Can I take a minute? There's no way to pause this timer, but I don't get to pause. There's lots of different ways you can think about a rectangle. You can think about a rectangle as from this point with a width and a height. So this is the x, y with a width and a height. You can think about it from here with a width and a height. You can even think about it based on just these two corners. I think I want to think about the rectangle strangely enough. I don't really love this because it causes some other problems, but I think it's just going to be easier for me to think of the rectangle from the center point. So I'm going to do that. So I'm back. So y is always going to be height divided by 2. Width of the paddle is going to be like 10 pixels, and the height is going to be 50 pixels. So probably have to change those later. So, and then I want a function called show. And I need to say rect mode center. And I'm going to say fill 255 for this as well. And I'm going to say rect x, y with height. And it's, okay, now where its x is kind of a tricky thing. And you know what I'm going to do? We're going to leave this. We're gonna, there's a better way to do this, but I'm not going to worry about it right now. Okay, so let's now, in here, let's make paddle, I'm going to call it left, and paddle right. So I want to be able to use that same template to make two objects. Oh, the power of object-oriented programming. So I'm going to say left equals new paddle at 0, and this is going to be wrong. And right equals new paddle at width. And then I want to say left.show, right.show. Okay, let's run this and see what I get. No, it's not so bad. There are the paddles. They're really small paddles. So a couple things. One is, notice how, because the center of the rectangle is right on 0, actually half the rectangle is off the window, which is fine, but just for, you know, just to keep things, I probably want to say its actual location is x, wherever it was given its initializer, plus its width divided by 2. Or minus, depending on whether it's the left or the right. Okay, better idea. We're going to use an argument here, Boolean left. So is it the left or the right paddle? So I'm going to make one puck true, one paddle true, one paddle false. I'm sure everybody in the chat is thinking of a lot of things that I'm doing wrong. I can't look at the chat. I don't know. Post a lot of, if there's something really major, I don't know. I don't know how to get my attention. Okay, so what I'm going to do is I'm going to say if left x equals w divided by 2, else x equals width minus w divided by 2. So I'm basically going to take a Boolean variable in, because there's only two kinds of paddles. And now if I run this, there we go. And I should make these paddles taller. Let's make them 100 pixels. And there we go. So now we're pretty good. We've got Pong. Oh, someone's saying there's usually a gap between the paddles and the edges. Okay, let's add that. Plus float gap. Oh, that's going to make it so complicated. That's fine though. Actually, it won't really. X equals W divided by 2 plus 10 minus 10. Let's just give it a little. Or actually, why don't I just use the full width? And the gap is however wide the paddles are. Okay, there we go. Pong. Oh, I got 9 minutes left. Okay, so here's the thing. First of all, I need to move the paddles. Oi, 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 oi. Attention, shift master, meister, false alarm. Got it. Okay, so what I need to do is move the paddles. Let's write a function called move, and it's going to move by some number of steps. So I'm going to say y plus equal that number of steps, and then I'm also going to say y equals constrain. So I don't want to let the user move the paddle off the window. Constrain is a function that says take this value and constrain it between 0 and height. Only I don't want to constrain it between 0 and height. I want to constrain it between, because x can't actually go all the way up. I want it to stop, y is the middle of the paddle, constrained between, I want to draw a diagram, but I'm worried about the time. I should never use these timer things. It's height divided by 2 and height minus h divided by 2. So this would now keep it, I'm going to draw a diagram, forget the time, right? Because if this is the edge, right, this is the y where it can't go up any further. And this amount is the paddle's height divided by 2. So that's sort of an important piece there. Now I have some errors here. Oh, I need a semicolon. So now how do I move the paddle? Okay, well, in processing, in addition to setup, starting the program, and draw, running the program, I can have a key pressed function. And in the key pressed function, I get an event. Every time a key is pressed, this code is executed. Am I standing in front of it? Let's move this over. So what I want to do is I'm just going to say if key equals A, I'm going to take the left paddle, and what do I call it? Move -1. That's up. Else if key equals Z, oh, I realize I'm going to have a problem here. Left move 1. And now I'm going to do the same thing for, I don't know, J and M. This terrible interaction ideas, but and this should be the right one. So now let's run this. Oh, look how little it moves. So let's change this. Let's have it move 10 steps every time I press, and I should probably make that a variable. Now, I can't hold it down. Oh, I'm really going to have to fix this. Boy, I'm going to need more time. I need more time. I got to fix this now, actually. It's kind of unplayable. The issue is I can't hold down the key. So this is a problem. What I actually need to do is whenever I press the key, I need it to start moving and not stop moving until I release the key. So, so what I'm going to do, this is a little tricky, but I'm going to take key released. And in key released, basically, I want to say left, stop moving. Or actually, I can do move 0, because I have that function, right, move 0. And the difference is, instead of this actually won't be so hard. So right, what this does right now, in the move function, if I go to the paddles move function, it's actually moving it in the function. But what I want to do is I want it to have I'll just call it like I don't know what to call this. I don't have time to think about it. I'll just call it y change, which is 0. And I'll also have an update function, which does this. So the update function always changes it by y change. And the move function just sets y change to a certain value. So in other words, I'm going to always left.update, saving the hardest part for last, left.update, right.update. So it's always moving, it's just often moving by 0. It's always moving by 0 unless I press a key. It sets it to move by a certain amount and stops once I release the key. And now I'm going to do this. So now this is quite a bit more elegant to play with. There's issues with I can't press more than one key at a time, but those things can be ironed out later. Okay, here we go. Now, did Pong, I see a question, did Pong repel in different angles depending on where it hit the paddle in the original? Ooh, the paddle was broken up into 8 slices that make the ball bounce at different angles depending on which segment the ball hits. Why? Why make this so hard? This is definitely going to take longer than that amount of time. But let's first at least get the, let me make this thing move a little bit faster here. Okay, so, why is it so slow? Okay, great. So first thing that I want to do is I want to check to see if the puck hits the paddle. This we can do. And because I'm using object-oriented programming, I can just have a little dream, fantasy state of how I might write this, right? If puck hits left, or if puck hits right. Puck, reverse, reverse. So, and actually what I want to do is, this is kind of like the idea, but you know what I'm going to do? All this can happen just in the puck itself. I can just say puck, check left, check paddle, left, puck, check paddle, right. Okay, so this is what I want to do. You can see here, it's got this red line. It has no idea what check paddle is. But the idea is that I want to write a function called check paddle that's part of the puck object that receives a paddle and checks if it's hitting it. And I have to do it do I have to do it differently with the left and the right? Kind of. Yeah, I shouldn't use reverse because that's a reserved word. Okay, okay, so let's go into the puck. I should have thought this through in advance. Void check paddle, paddle P. By the way, you'll notice here, I didn't write a constructor function. Technically don't have to, unless you have some type of logic that you need to execute in the constructor function. All I had were these set variables, so I don't need one, although, proper object-oriented programming would have me write just this blank function that would get called when I say new puck. Okay, check paddle. Check paddle. Check paddle. Okay, let's just pretend all I'm thinking about is the right paddle. If x is greater than paddle.x and y is less than paddle.y plus paddle.y. Oh boy, I'm just going to do it. Paddle.y, I don't love this. Paddle.y plus paddle.y plus paddle.h divided by 2. And y is greater than paddle.y minus paddle.h divided by 2. I hate this long, awkward if statement. There's so many ways I could probably make this nicer. But this, look at this horrible gobbledygook. But let's use the fact that there's 1 minute left to explain what I'm thinking about here. You're going to hear a ding sound. Actually, you won't if it goes off while I'm over at the whiteboard. So I have to, okay, I'm going to give myself some bonus minutes. So in other words, I want to know if the x has moved past paddle's x, but I want to know, this is paddle's y, if the y is in between paddle y minus h divided by 2 and paddle y plus h divided by 2. So that's the section that I want to look at. I kind of want to refactor this so badly to make it nicer, but this is kind of will work. How am I on time? Oh, a minute left still. So if this is true, I want the puck's x speed to change to multiply itself by -1. And this is going to work for the right paddle. So let me just only right now check the right paddle. Let's just see. Oh, quick, move down. Oh no, move down. No. Hey, there we go. Okay. This really looks so wrong, right? Right, because you can see here. I really. First of all, it goes way past. So I really have to. I'm sorry, I'm losing. I really have to deal with the fact that the puck has a size. I'm just looking at the time. How much more time should I give myself? How about 10 more minutes? Oh my God, that was really loud. Let's give myself 10 more minutes. By the way, if you want to know how to program a timer in JavaScript, I previously did a coding challenge where I made that exact timer. Okay, 10 more minutes. Let's see if we can do that. Okay, so we've really got to deal with the fact that the puck needs an R. So its size, I like the size of it, is reasonable. I was drawing it at 24, so the radius is actually 12. And you know what I kind of want? I want the paddles variables to be half height, half width. It's going to be much better that way. But we'll worry about that later. R times 2, R times 2. So there's a couple things here. One thing that I want is now in the paddle, in the puck, to check if x plus r, right? Because if its right edge is past the paddle's x, and not just past the paddle's x, but past the paddle's left edge, which is minus paddle w divided by 2. Oh, my kingdom for some clean, not so horrible long if statement. But let's just look at this and see if this looks nicer. Which key do I move it down? There you go. Oh, did that? That didn't look exactly right. Did it? I can't tell. It's moving so fast. Hold on. Oh, that's perfect. Okay, I saw that's perfect. Okay, so that's great. So that works for the right paddle. Here's the thing. I think what I need to, the problem is there's a little bit of an issue, which is that I want to check if the x is greater than the x for this paddle, but I want to check if it's less than for this paddle. So I think what I need is to indicate, because I could do some more sophisticated thing where it could bounce off either side, but it doesn't do that in Pong. So I might want to pass that function maybe a +1 or a -1, depending on which side of the paddle I'm coming from. I could also just write two different functions. I don't know what's best. But let's try my goofy way of giving this a number like direction. So this is like the direction it's coming from. So in other words, I'm going to check right. It's coming in the positive direction. I'm going to check paddle left. It's coming in the negative direction. So in that case, let's look. Can I do something like this? So I want to like format this in a way where I can kind of see it. Like these are the things I'm checking. If x plus r is greater than. So and this is, well, direction, this is minus. So I should really say plus minus direction times, right? Because I want to check on this side the x minus, but on the other side I want to check the x plus. So, and this needs to also be, this needs to be plus direction times r, right? Because r is, am I moving to the right of it or to the left, whether it's going, and then this has to become less than. Now, how can I turn a less than to a greater than with, I could just use the puck speed if it's going to the right or the left. That's a good point. How can I change this? So here's the thing. Let's just do this ridiculous way. So first, all right, let's break up this if statement. I don't like what I'm doing here. Let's just check these things first. Let's just check if the y is in between. So if the y is in between, which is just this if statement, then we can move on. If direction equals -1, then check the x value if it's less than. And I can actually just do this because I'm going to be lazy. Make it, right? I can check this, and I can put this as an and. If direction is -1, and so I actually don't need this direction I don't need this direction because I can use the x speed. Okay, I got it. We're going to take this out, and we're going to say if x speed is less than 0, that's the -1 direction, then I'm checking it against the right edge of that paddle. And if that's the case, x speed times equals -1. Else, if x speed is less than 0, and now I need to just do the opposite thing. So if it's moving to the right, actually, by definition, it's moving to the right. Else, if, oh, camera went off. Time out, this will get edited out. Actually, no, it won't. Camera went off in the middle because the timer's still going. X plus r is greater than p dot x minus p dot w divided by 2. Then also, and I'm sure I could join these with an or. Oh boy, I made this so convoluted and complicated. But now let's think about this. This is very, very hard to read. This is not so friendly, but this is what we're doing. First, I just want to know, is the paddle's y position between the top and the bottom? Then, is it on the right side of the screen? Is it moving to the right or is it moving to the left? If it's moving to the right, check if it's gone past that paddle. If it's moving to the left, check if it's gone past that paddle. Let's see if this works. Oh, and I don't need this direction thing anymore. That was a digression that seemed interesting but unnecessary. And now, oh boy. Oh, look at this crazy, crazy puck, crazy Pong. Whoa, strange issues. It's just a flag with -1 or +1 and multiply. People, that's probably a very good idea. But what did I do wrong? If x speed is less than 0, there should be like a pause here for debugging. Okay, let me think about this. If x, the problem is I need to sketch this out while I'm looking at the code. Oh, this camera went off too. Sorry, everybody. Coding challenge disaster. Okay, wait. Hold on. Okay. Let me check this out, right? So x speed is positive. The puck's x should be greater than the paddle's x minus, the puck's x plus r should be greater than the paddle's x minus its width divided by 2, right? These are the points we want to check. If it's greater, plus x, puck x minus puck width divided by 2 multiplied by 91. Otherwise, if x speed is less than 0, that seems right. But really, here's the thing. Why have the same? The thing is, what did I do wrong? X times equals -1. What did I do wrong? Let's run this again. Oh, whoops, I refreshed the timer. That was totally by accident. Oh, it's getting stuck. So first of all, I'm panicking, everybody. It's getting stuck. Why is it getting stuck? X minus r. Let's just look at. First of all, let's treat these separately. Let's treat these separately. So let's just look at the right. Let's just check the right paddle first. What did I get wrong here? I need another close bracket. This is me debugging. So much for my timer. Okay, so why is it stopping? Because it changes. Oh, it's not updating. It's not moving off. So it's still there. Because where do I check? Then I show. Then I update. It should move though, because it's checking. It should get a chance to move. I mean, so if we just, I guess what I could say here is x equals p dot x plus p dot, I could just shove it. I could shove it off to the, wait. Oh, I'm on the wrong side here. This is the side that I want. What I could do is if it's moved past it, I think this is the same as the gravity bouncing ball problem. I could just shuffle it right to its proper spot, which is p dot x minus p dot w divided by 2 minus r. Oh. Oh, it's checking. Oh, this is like a terrible thing that I'm doing. No wonder. This is awful. This is like an awful thing that I've done. Because this is still like the right paddle. So it's still checking this. I can't actually do it this way with its x speed because I actually only wanted to check the paddle based on its direction. Oh boy, can I have a mulligan here? Can we edit this part out? I said I wasn't going to do it. So, this isn't going to be that short 12-minute. I'll do another version of this in JavaScript where I won't make these mistakes. Okay, I'm going to be really methodical. I'm going to unfortunately have to do a terrible thing that I wanted to avoid. Check paddle left. And that's just going to be checking. This is the right? No, this is the left. Check paddle left. So forget about this x speed thing. I have to check all these things. I ran out of steam here. And this is going to make this much easier. I was trying to reuse the same function. And I think I should just refactor this later after I think about it. Check paddle right. And then now we need to say if it is still within the paddle, but the x is different. And the x is x plus r is greater than this minus. So now we should be good. So now what I just need to do is I just need to say check paddle right and check paddle left. I just need a slightly different algorithm for each paddle and 2 different functions. That'll do it. Okay, there we go. Now, the other thing that people were saying is the angle should change based on where it hits it. Let's implement the score first. I've got 5 minutes. Somebody tell me so the angle should change. So this has to do with angle. So actually, no, never mind. I'm going to do something here. So here's the thing. Remember when I said I wasn't too happy about the way I created this initial speed? Well, I don't actually want to create a speed. I need the whiteboard here. Everything you ever want to do is more complicated than you think. If I pick a random x speed between like -5 and 5 and a random y speed between say -5 and 5, I could potentially pick an x speed of 0 and a y speed of 0. That's not what I want. What I actually want is to pick a random speed that's always maybe going 5, but is just in a random direction. So what I really want is a random angle between 0 and 360, or between 0 and 2 pi. And I have this other video. It's called Polar Coordinates. You can go look up that right now. Because if I pick a random angle, I can then say x speed equals whatever speed I want, like 5 times cosine of that angle, and y speed is 5 times sine of that angle. So this has to do with a right triangle and sine and cosine of that angle. And I go through the math for that in another video. Okay, so now what I'm going to do here is I'm actually going to take this out of here. I'm going to do this in the constructor because what I want to do is float angle equals a random angle between 0 and 2 pi. And I want to say x speed equals cosine of that angle. And I'm just times 5. And y speed equals 5 times sine of that angle. So now when we run this, we should see the puck always going at the same speed, but in a different direction. So the reason why this is important is because this angle thing, I think, is actually technically a variable that I'm going to want to keep track of. Oh, vectors, I should be using vectors. That's okay. We're going to be fine. Okay. People were taking bets on how long this was going to take me, and I think somebody's about to win. Okay, so now what can I do here? So now this should also, by the way, this algorithm should go in that reset function, which sets it back to the middle. And then, by the way, why not in the constructor just call reset? Now, I wish I could keep track of the angle and then I could just... Okay. Let's run this. I'm playing it. Okay, come on. This is pretty good. Hey. Kind of made Pong here. Oops. Whoa. Well, that's bad. That's a bug. Look at that. Okay, so I got to deal with, there's so many bugs. I shouldn't pretend, I should not made that happen. Okay, so here we go. Let's at least add the score. Let's do something satisfying. I'm going to add score into sound. Okay, so I'm gonna say left score and right score. And I'm going to put those on the screen. I'm going to say fill 255, text left score, 10, I don't know. I'm just going to pick some location and text right score. And I should, width -10, something like that. Let's try that. So let's see if we get the score. Whoops. So you can see the score is there. I should make the font size a lot bigger. And then maybe make this in a different spot. Okay, you can see the score is there. Yay! Okay, now let's start adding some points. Where do the points increase? We're in the puck, the edges issue. If it goes off to the right, this is left score gets a point. And I don't love the fact that I'm using this global variable here in the puck object. I probably should return, and the score is really sensitive, but just for the sake of quickness here, I'm going to say right score ++ here. So now, let's see if we can get some scoring going. 1, 1, 2 to 1, 2 to 2, 3 to 2. Okay, so we've got score. So in a lot of ways, we're in pretty good shape. Let's add a sound. Do I even have the sound library? Import sound. Okay, so what did I just do, by the way? Under Sketch, Import Library, I can go to Import Library, Import Sound. If you don't have the sound library, you're going to have to go to Add Library. It'll bring up this menu, search for sound, hit Install. Then you'll have the sound library. So I have the sound library. I'm going to say psound, I think is called. Ding. And then psound equals new psound ding.mp3. Maybe I have to say this ding.mp3. The timer went off. Oh my God, it's scared. Let me get to me. Oh, can I have 10 more minutes, please? 10 more minutes. There we go. I knew this was useless. It's not psound, apparently. Let's look at the... why am I adding sound? This is really... Oops. This is really just taking up a lot of unnecessary time. Processing sound. Sound libraries. I want to look at sound file. I don't know why I said psound. Sound file. I just imagined it was called psound. Sound file. And then, and let's just call it ding. And ding equals sound file. And then let's have it ding. Should we have it ding every time somebody gets a point? Ding.play. Ding.play. Okay, let's run this. Oh, that's so loud. Is it loud for you guys? Oh, come on. This is like that thing in air hockey where it gets to the middle and you have to walk around and pick it up and put it back. Really, just while I'm testing the sound, and now you're going to bounce off of the puck? Okay, we can restart it. Can you guys hear that sound? Volume is fine, okay. Okay, so we've kind of got Pong. Here's the thing. Oh my God, stop. Okay, there's a couple things missing here, a lot. One is there's a bug that the ball can get stuck behind the paddle. So we should really deal with that. Number two is, I think I know how to deal with that actually. That's gonna be an easy one. Let's fix that. Because I'm realizing that what I'm checking for, really if it just gets past the middle of the paddle, right? So I think that's really the issue. The edges isn't really, it's really like the width minus, what is it called? Right paddle? Right? Minus right minus right dot W, right? And then this is left dot W. So I really just want to check, not if the ball gets all the way to the edge, but just a little bit past the paddle. Although, is that going to make it disappear in a weird way? Maybe, well, so maybe it's okay if it gets all the way to the edge. Oh, so maybe it's not about that. Maybe it's actually, so I don't like that because we want it to go, and it really should be if x, it should get all the way off the edge. If x minus r is off the edge, and if x plus r is less than 0, that means it's all the way off the edge. Now, what I really should fix is here where I'm checking the, checking this monstrosity here. Because what if it should only actually reverse its speed if, as long as also, I should also just double check, as long as the x is not greater than maybe the other side of the paddle. So not greater than p dot x plus w divided by 2. So as long as it is, right, because if it's already gotten, so it might get past the paddle further away. So as long as x is actually less than, it has to be greater, that has to be like really within the, within the paddle's bounds. So I saw starting angle, yes, the starting angle should be constrained. Okay, good point. X is less than, as x is less than the paddle's x, just say the paddle's x. Like it should be between the edge and its center. So this is like a quick extra double check to make sure it's not kind of behind the paddle. And this is another quick double check to make sure as long as it is greater than paddle.x. Okay, so let's try this. And now we should, okay, I'm going to constrain that angle. In reset, what we're going to do is we're going to constrain the angle between negative pi, 45 degrees, which is pi divided by 4, and 45 degrees, which is pi divided by 4. And so that will always give me something pretty much pointing to the right. But what if I want randomly to go to the left sometimes? So I can say, my chicken is ready, my tofu, whatever, tofurkey is ready. Okay, my toast is toast, that's what I was looking for. If x be, oh, this is horrible. If you've made it, hashtag ding, 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 if you've made it to the end of this. What was I doing? Oh yes, if random, 50% of the time, let's have it go the other direction. If random 1 is less than 5, let's have x speed times equals -1. So I'm always picking an angle between -45 and 45 degrees in this direction, but half the time it might go the other direction. Or I think I might have fixed everything. Oh, it looks like it's off, right? It's not. Look at that. So what's wrong here? Well, let's see if this side is right. Oh boy. I think I have my, can I please take a break? I can't. I will finish this. I will finish this. So why is that off? It was working before. Let's look at this. Oh, I wish I didn't have this horrible if statement. I hate my horrible if statement. Okay. Stop dinging. Okay. Let's take this out for a second. Let's also just make the angle always 0. Just so I can test this. Did that mess something up? No. Okay, so something is woefully wrong. And is it bouncing in the right part here? It looks like it's a little bit off, right? Yeah? Okay, so let's see if we can figure this out. What did I screw up? Paddle, check paddle right. Let's check the paddle right. Okay, if y, okay, the y thing is right. It's the x. If x plus r is greater than the paddle's x minus p dot w divided by 2, that seems right. I have an extra speed minus 1. Where? Oh, look at that. Oh, no wonder. That's going to screw stuff up. Okay, I think it's working now. Is it just me that it's visually like, I feel like it should get a little closer. Oh no, it's working. Oh, it's just because it moves 5 pixels per frame. So it's always, it's, you know, my, it's sometimes not going to appear exactly, but that's right. Okay, now let's put this back in. What did this do? Let's make sure it's also within a certain range. Okay, that's good. Oh, it was working. I had that extra thing there. Now let's give it a random angle again. A random angle. Where did I do that in Puck? Let's take out angle equals 0. Okay, now we're going to play it. Here we go. Oh. So let's see if I can make that bug happen. Yeah, okay, that bug is gone. It's not getting stuck behind it anymore. So everything is actually done except for one big thing. The angle that it moves, the way that it changes should actually change according to where it hits on the paddle. Attention, Shiftmeister. Okay, that's a good way to catch my attention. Okay. Oh no, the timer's gonna go. That's like the 3rd time I refreshed it to 10 minutes. Am I like 45 minutes into this now? Oh my God, this is hilariously embarrassing. Okay, so I should do this in multiple parts, but I'm just not. I should just consider myself done, but I'm not. We're gonna finish this out. I need some ginger tea here. 48 minutes. Okay, I can at least finish it before an hour. You do realize I'm doing this live on a live stream with other people watching, with like lights on me, standing up in a very stressful mind. I'm wearing like a light up bow tie. Now we're just getting ridiculous here with this timer. Okay. All right. Oh, I walked over here. Why did I walk over here? So let's think about this. We're going to call, I think the title of this video should probably be Pong in 60 minutes, because I think it's going to be a 60-minute video. Okay, here we go. Now, here is the paddle, and here is the puck coming at the paddle. So what we're saying is, if it hits in the center, maybe it would reverse its x direction precisely and not change the angle. But if it hits closer to the side, it would then project further down. So we'd be rotating the angle by some amount the further down the paddle it gets. Is that correct? And same thing, but what if it hits up here? Would that cause it to also rotate further down because it's just based on the distance to the center? Or would that actually have it reflect further in? Which one is it? Somebody help me out. I don't know how Pong actually works. Like, is it always Somebody tell me. Can we pause this video for a minute? I'm waiting for the chat. Thinking will waste time. Yes. Further in. What is the further in? What does that mean? Be more specific. Okay. Let me look in the code to where I need to do this. Depending on the movement direction of the paddle. Middle third is straight on. The paddle is like a circle, and the angle reflects the angle from the center. If it hits on the very corner, it should go in the opposite direction. Further at the top. All right, so if it hits further up, angle goes up. Hits further down, angle goes down. Reduce the angle. Incoming angle doesn't matter. Top is reflect up. Top third ricochets up. Divided into thirds. Okay. Here's the thing. I'm trying to avoid actually using the angle because then I'm going to have to get into tangent and all that stuff, and I should have just used vectors in the first place. Oh my God. Adam J. Austin, sorry, in the chat just posted a... does it actually just give you, where it hits, it gives you a specific angle no matter what its direction is? That's perfect. How do I Google for that? There's no angular reflection. This makes it so easy. Adam J. Austin, how do I Google that image? How'd you find it? Puck angle direction. Oh, that's not Pong paddle angle direction. Oh, this makes it so easy. Where is there a picture? Where's that picture? It came into the Slack channel. Can someone just tweet it to me at the coding train? Pong angle segments. Thank you. Pong angle segments. Okay, Pong angle segments. There it is. Oh no, that's in this one. This is one. Okay, this is totally manageable. Look at this. So here, this is so much easier to deal with because it doesn't actually matter what angle it's coming in. It just goes at that angle no matter what. So what I'm going to do is I'm actually just going to map the angle. I don't even need to divide it in segments. I can be fancier and have it be continuous. So I just need to take its y value, its y position from 0 to the bottom and map it between negative 45 and 45 degrees, or negative 135 and 135. Okay, let's do this. Okay, so where does it hit the paddle? Over an hour was the correct answer. Okay. This is where it changes speed. But now, forget about all this nonsense. All I want to know is I want to know the difference between I want to know its y location minus the paddle's y location minus, I really should have the paddle keep track of its top and bottom location so I don't have to keep calculating them all the time. But I want to know how far from the top is y. And then I want to have an angle. I can use the processing map function where I take that difference, which goes between 0 and p dot h, 0 to the top, right? It could be all the way at the bottom, or it could be all the way at the top, and map that from negative 45 to 45. And then x speed equals 5 times cosine of angle, and y speed equals 5 times sine of angle. And then I'm going to do the same thing for the right. The difference is I want the range to be between negative 135 and 135. What did it say in that? I might have to rethink. I probably have to rethink these angle values because I have a computer graphics window and angles point down. And also, hello, radians, people. Radians. Let's just convert this to rad equals radians of 45. So I want to go from, I could do, it's pi divided by 4, but I don't feel like, and I'm sure this is wrong. Radians 135, negative rad to rad. Okay, let's just throw caution to the wind here. I'm sure it's wrong. Yeah, okay. So first of all, you can see how I have it, it's going in the other direction. So this one should actually be 45. Stop dinging. Hold on. Does it still ding if I turn my volume off? Maybe not. Okay, let's try it again. That doesn't look right. Is that right? Or is it going oh, that kind of looked right. Is that right? That can't be right. Whoa. So I think okay. So it's clearly wrong. So let's think about, okay. Let's think about what these angles actually should be versus that diagram. I should never take a diagram literally. Okay. Okay, so this is the diagram. Let's just look at the left one, okay? And I can see what the problem is already. Oh, no. That's actually correct. This is computer graphics because the left one should be between negative 45 and 45. That's actually correct. Hold on. Because I was concerned that it's flipped, but if you rotate, or sine and cosine, all right, let's make a separate sketch to be sure about this. Okay? We're going to figure this out. 0 is to the right. 0 is to the right, but do sine and cosine, they do the actual math and they don't know about the axis being flipped, right? Or do they? I don't need draw, right? Because what I'm saying here is, let's do this. What I'm doing is I'm saying I have size 400, 400, and I want to draw a line from width divided by 2, height divided by 2. Let me just do 200, 200, 200, 200 to 200 plus x, 200 plus y. And I'm going to have an angle equal negative 45. And then I'm going to say x equals 100 times, okay, hey, stop, 100 times cosine of that angle, and y equals 100 times sine of that angle. Okay, so it's doing exactly what I thought it should do. Kill the timer, it doesn't matter anymore. Okay, so this is right. Oh, sine, no, sine should only do this for the y? I don't, Okay, so this is right. I feel like though that this is, so maybe my positioning is wrong. So let's see. So if it hits, so that's right. Let me go back to my other sketch. This is the left paddle. Okay, I got something wrong here. It's the mapping that's probably wrong, right? So this should be 45. So this should be 135, right? I had it right the first time because the difference, if it's at the top, y minus, the paddle's y minus, oh, hello. It's not, it's y minus the paddle's y minus that, right? That's the actual top location. That's the difference. That needs to be in parentheses. That was a big mistake, right? Because that's the difference. And it's kind of counterintuitive to me, but, right? And this is the same issue. Okay, so now, let's see what I get here. There we go. Yeah, doesn't this look right now? Oh, I feel so happy. Pong. Oh, wait, why did it have a bug? What was that bug? I don't like that bug. Oh, you know what the bug is? I know what the bug is. I think the bug, it kind of like skips past it because the paddle moves kind of fast. And I mean, the puck moves kind of fast. And this check is a bit of a problem. This extra check that I put on first so it doesn't get stuck. I think what I really want is, let's check as long as it's greater than, let's look at the right edge. So because sometimes it's going past, it's able to skip past that middle. Because it's only 10, I could make a wider paddle and then I wouldn't have this problem. That's probably what I should just do. Because my speed is 5, but I could also be, so let's just make a wider paddle. Let's make a wider paddle. Yeah, we're not going to have this problem anymore. I'm terrible at this. Okay, hey, I did it. It only took like an hour. Oh, watching the beginning of this video is going to be so sad. But this is Pong. My left hand, who's going to win, left or right? Oh, it did that again. Why does it do that? What's that bug? I think it's, oh, I know what the bug is. So actually here's the other thing I should do. If I want it to bounce off the right edge, it can skip over the right edge and be told to move back. But I think I should really, probably to be safe, I should always place it back to the correct location. So I should also say x equals the paddle x plus the paddle's width divided by 2. And here I should just shove it back, x minus equals the paddle's x minus the paddle's width divided by 2. I think this is also going to make it feel a little bit more accurate. 1 hour and 1 minute. There we go. Okay, I have to stop. Well, that was a little bit weird. I thought that was it getting stuck on it. Maybe I was still moving the paddle is the problem. Oh boy. Oh, I must have messed it up. I made it worse. Oh, I forgot about R. X equals, I want it to go on the right, also minus R. And I want this to also be plus R. This is going to be done. I swear this is done. If I had done this in JavaScript, it totally would have taken me 15 minutes. Yay, Pong. Okay, thanks for watching. I hope you enjoyed this. It only took apparently 61 minutes, and I don't know what else I'm going to do, but this video is over. If you actually watch this whole video, then I commend you. You are amazing. You are a part of my heart, and I will give you an internet hug and send you on your way. Goodbye. The stream is making me anxious. Hey, all right, everybody, before I go, somebody in the chat just said the stream is making me anxious. Oh, shoot. My soundboard's not working. Let's just take a deep breath, everybody. Okay, goodbye. See you soon. Bye-bye. Okay. Oh, are my angles? 15 minutes, you guessed it correctly. Who had 61 minutes? Slow clap. Change the speed. Okay. That was fun. I guess I should tweet then update. Don't forget to increase the puck speed on each bounce. I'm getting some tweets here. Oh, set interval is a very wrong way to make a timer, I was just told. Okay, hold on. Let me look at this. Oh, why is set interval so bad for making a timer? The reason why I didn't want to use the draw loop. I felt that was unnecessary in a just because then the machine is cranking constantly where I just want to do something every 1 second. But anyway, that's good feedback. I guess I'm going to get a lot more comments about how doing a timer. There's a guy on YouTube who is done in minutes in HTML JavaScript. Yeah, but did he do the score and finagle all the perfectness that I didn't really get right? Can I have a mulligan? It went through the side of the paddle. What if I do this again? in JavaScript before I go, and we'll see how long it takes. I actually also wanted to experiment with this thing called glitch. Have you guys heard of glitch? Let me go here to the browser. Glitch is, I made an account. What's the chance I can just sign in with GitHub, because I won't be able to log in with GitHub because all right, I have to go to my 1Password. Oh, I'm like way off the chat. Oh, it stops when the tab is in the background. Oh. Oh. Maybe I shouldn't release that timer tutorial. Oh, let me do an addendum to it. Hold on. So hold on. Let me come back to, do I still have that timer going? And I should probably do something for the beginning of the, Pong video. Okay, hold on, here I am. Okay. Oh, why is it doing, oh, what did I do to this? Oh, it's minute, not minutes. Okay. Okay, I'm just going to do a quick, for if this timer video gets published, I need to do a quick, I need to do a quick addendum to this. Okay. Hello, what you are about to watch is a coding challenge where I make exactly this, a simple little countdown timer in JavaScript. And when I begin the challenge, I'm going to say, hello and welcome. I'm going to do blah, blah, blah. But I'm adding a little bit to the beginning of this because there are some problems with the way that I programmed it in this challenge. Number one is I use something called set interval. And what I learned, thank you to the chat that watched this along with me live, is that this timer, look at it, it's at 9:12. I'm going to go over here to the processing website. It was at 9:12, a second passed, another second passed, another second passed. I'm going to go back to here. Oh, maybe it works fine. Hold on, let's test that again. Why didn't that have a problem? Was that 9 minutes? Use the timer to see how long it takes, not to limit your timer. No kidding! I learned that the first time around. Yeah, I feel like it's still going even though it's in the background. So why is that happening? Wrong. Set interval, somebody in the chat, because Google is, oh, this is a change that's going to happen soon, right? Maybe they haven't implemented. Request animation frame stops when the tab is in the background. Okay. So maybe that's fine. Try minimizing Chrome. Okay. 8:04. It was at 8 minutes, right? The thing is, I was just demonstrating an idea. If you were putting it into like a Canvas game and you're never going to like switch away from it. Yeah, that went 15 seconds later. So I guess set interval, so maybe that isn't an issue. Yeah, but request animation frame. Millis is a, so, but there are some accuracy issues. So let me try to record a little brief intro to this again. Hello, what you're about to watch is a coding challenge where I make exactly this above me. It is a timer, a countdown clock in the browser. I make it with JavaScript and the P5.js library. Now, it was pointed out to me in the chat there are some issues with this. Number one, I use set interval. It doesn't actually have this problem, but sometimes with other, shoot. It's not an issue because YouTube keeps playing when I switch tabs. It'll make your life a lot easier by doing so. Redo Pong in assembler. I don't know if I need this addendum anymore. I guess I could just put it in, maybe I'll just put it in the description. Tell me why Millis is so much better. I mean, is it just because it's just so much more accurate? Set interval is going to have slight inaccuracies. If the browser is busy, set interval will not fire at the requested time delay. Okay. Now I've got it. Thank you, everybody. Hello, welcome to a coding challenge where I make exactly this, a countdown clock timer in the browser. Now, I did it with a function called set interval because it's a nice demonstration how set interval works, and it works. It's really nice. But I have to admit, I've learned since after making the challenge that it's not such an accurate way of doing it. Number one is if the browser starts to get locked up, set interval isn't actually going to happen at the correct time, and so your timer can slowly get off over time. More accurate would actually be to check the milliseconds of since the page was loaded, which is something you can do with a function called millis in P5. So you can watch this video. I hope it'll be interesting to you. I'm going to make a part 2 where I redo the timer using millis, and it's perhaps a bit more accurate. But both of them are interesting, useful ways to program things. Okay? Enjoy. Okay. Okay, the question now I have is, so if I'm going to update this, please don't do it again. If I'm going to I'm not going to do the whole timer again, but I'm just going to do maybe I'll do a quick addendum at the end. It was kind of such a short video anyway. If I'm going to update it with millis, is it still okay for me to just use set interval? It'll correct itself even if set interval is a little bit off. Because maybe I don't want to have the draw loop if I don't have the draw loop. And request animation frame will also go to sleep. But maybe that's fine. Now add multiplayer for the Pong. Do Pong in JavaScript again? No! Okay. I need a way of polling. I wish the YouTube chat had a poll. That would be perfect. Sure, no need for the draw loop. Okay. So let me go back to the timer. Okay. So, okay. Okay, I'm back actually at the end of this video to do a quick addendum. I'm just going to change this timer to use millis instead of actually using set interval to rely on a specific second pass. So even if set interval is off by a little bit, millis will never be off. So let's look at how I could do that. So whenever the timer starts, and I guess the timer starts just when the page loads, I'm going to have a variable called start time. And I think reliably, the millis function is going to, when the script first loads, is going to be at 0. But I'm just going to, for the sake of argument, I'm going to say start time equals millis. So I'm just going to, when setup runs, I'm going to check and see what the start time is. Then what I'm going to do is in the timeIt function, forget about this counter thing. The counter is now completely irrelevant because what I want to do instead of having the counter is, and I'm going to call this current time. I want to say current time equals, what do I want? I want the current millis minus the start time. And then what I want to do is divide that by 1,000 to get the number of seconds, right? Because if 5,000 milliseconds have passed, that's actually 5 seconds. And because my timer is just by the second, I don't worry about 5.3, 5.23 seconds, although you could make a more sophisticated timer that does that. I'm just going to say floor, and I'm going to floor that to take off the decimal place. So now I think, let's just see. I have an error. Sketch.js line 35. I guess I'm missing a parentheses here. Because what I want is this divided by this and floor the whole thing. Okay, let's come back, reload, sketch 30, counter. So I guess I have a reference to 30 still. Oh, right. Oh, time left minus, so current time needs to be a global variable. So current time And then in places where I'm using counter, I need to say current time. And probably here too, current time. And did I use 2 T's in current time? I did. So let's go over here. Let's first of all move this like this if I have. Okay, so now it's the same exact timer, but I'm pretty sure it's more accurate. If I were able to do something like lock up the browser, that doesn't really do it. I was trying to figure out a way to lock up the browser, then that should work. So this should be better. There we go. I'm seeing lots of things in the chat, like maybe I'm doing this incorrectly. But I think that's the end. Millie's does handle start time for me. So I probably could be fine with actually, let's just see. I'm gonna get rid of this. Yeah, so I don't really need to, I'm gonna get 0 by definition. That setup is gonna kind of run right at 0 milliseconds. But the reason why I'm doing that is if I ever want the timer to restart, I need to start at some other milliseconds. Okay, thanks for watching this video and I'll see you soon. Okay. All right. Pong, 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 pong. Dare I try this again? JavaScript. What are some things I can do to make it simpler? Counters that tick are not accurate over time. It's enough for me to do it right, though. Okay. I think I might, oh, this is a 2-hour stream all of a sudden? When did that happen? And all I did was Pong? All right. Show how to make it in pure.js. Oh God, no more Pong. It would be nice for it to be the weekend, don't you think?
As always, I always forget the this
Why
dot,
is
this
my-
dot, this dot, this dot.
Oh.
I'm gonna do this dot, this dot. I'm gonna do this dot.
Oh, that was-
this dot, this dot. I'm gonna
You were actually getting my sound. When I said we should relax and play the lullaby, I just couldn't hear it. Time flies when you're, oh. Okay, what else do I have on my list? Binary tree. I'm willing to do one more thing today. Let's go look at my list. I wanted, let's go look at my list. Okay. Oh, I did 2 things. Binary tree, processing in Eclipse. I really wanted to do this. Maybe I should do that. So here are some choices. I want it to be in P5. I do think it would make sense. I do think it would make sense to do something in P5. Randomizer. Okay. Pong in JS. I kind of wanted to do Pong with DOM elements. Wouldn't that be fun? Pong in JS, DOM elements. These are some choices. Elements with P5. If somebody in the Slack group wants to make a poll, we could do things that way. Unfortunately, nobody in the YouTube chat. I could do another Twitter poll, but I feel like, I guess I could do a Twitter poll from the Coding Trains account. Let's do that. I feel like that's less, I'm less spamming people. And I'm logged into that here. Okay, so let's do a poll. Okay, so what are some choices? Pong, again. Pong. The problem is, if I put so many Pong options, it's going to dilute anybody who wants. Pong JS, Pong P5 canvas, Pong JS DOM elements. What I mean by DOM elements is no canvas. So it actually have like paragraphs and divs as the things moving around the page that actually play Pong. Processing in Eclipse Making a library, whoops. That's making a library part 1. Well, I can only have 4 choices here. And another choice was, what was on my list? Another choice was Chrome extensions. Prototype, inheritance, JS. Boy, this is such a sad little list. Oh, binary tree. What should I cut? All right, we'll have a revote. Pong again. And then if Pong wins, we'll have a revote for how I'm going to do Pong. So if you really want like the Pong with DOM elements, vote for the Pong. And then binary tree. Okay. Okay. So here's what we're going to do. I am going to give this poll length exactly, I don't know, 10 minutes? 10 minutes. I mean, I'm not going to wait around longer than 10 minutes before I start. So let's do that. Okay, here we go. And watch, this is exciting because you guys can watch this now in real time.
As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this
As everybody
this
goes
dot,
to sign up for a Twitter account.
This dot, this dot, this dot's on. This dot, this dot, this dot. Never forget this dot.
Oh, did I do one day? I thought I did 10 minutes.
This dot, this dot.
Oops.
This dot.
I did one day. Whatever. In 10 minutes, we'll cut it off.
This dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this
Sorry
dot,
about that.
This dot. I'm gonna do dot, this dot, this dot, this
Yeah.
dot. I'm gonna do this dot.
Pong multiplayer is not an option. That's a great idea. And Tom Igo has a bunch of tutorials, I believe. Actually, I shouldn't just, I believe there are, I'll try to find that. I think there's a tutorial for doing like some, I did one day in 10 minutes. Oh, good. Uh-oh, somebody's coming in.
Hey,
Hello.
how you doing?
I'm live right now.
Are you
Yes.
doing
Do you want to, I'm in the middle of a broadcast. There's people here. You can say hi. This is Dan O'Sullivan. Uh-oh. Welcome. It's actually good because I have a live poll going on right now to see what I'm going to do next. So,
Oh, he's doing a poll about what he should teach next.
so 27% Pong again, 32% binary tree, 25% processing eclipse. So I was actually taking a 10-minute break.
Oh, great.
So talk amongst yourselves for a second. They can hear anything we say. I could mute my
Oh, is
microphone.
that for St. Patrick's Day? Very nice.
No, this is
Is
Natasha's.
the green for St. Patrick's
The green is for St. Patrick's Day.
Are these yours, these things here?
No, so that's a long story.
Okay.
Anyway, so he's in the middle of a
Okay, I'm back. Can you hear me again? Okay, let's see how this is going. Ooh, binary tree. This really shows the audience here. Ooh, Pong again. Pong again has quite a binary tree. Crap, I was on mobile, tried to hit Pong and hit tree. Okay, hold on. Why was the music stop? Oh, because I paused it.
I'm gonna do this dot, this dot, this dot. I'm gonna do
Oh, everything's
this dot,
playing.
this dot. I'm gonna do this dot, this dot.
Here, I think I should read some random numbers. I need some other books to read. By the way, April, it's not April yet. April is National Poetry Month. I will be reading poems on every live stream. So if you have some good poem suggestions, please let me know. Because I like to do whatever possible to be the least like a programming channel whatsoever. And I feel like reading poems helps with that. Okay. Hold on. Let's do some math here. Will someone please time how long it takes for me to read one line of numbers? Okay? 77,763, 66,045, 91,851, 2,199, 34,221, 58,116, 6,648, 55,779, 50,353, 16,401. Okay, how long did that take? Now let me count how many lines are on this page. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 22, 23, 24, 25, 26, 28, 29, 30, 31, 32, 33, 34, 35. Hey, guess what? These are in groups of 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 50 lines. It took about 22, oops. Let's say it took 20 seconds. Let's say if I had to go it faster, it took 20 seconds. I'm going to round. 20 seconds. And what did I say? 5, 10, there's 50 lines. So let's do some math here. 50 times 20 is 1,000 seconds per page times how many pages? Page 1 all the way to page 1, all the 400 pages. That makes sense because it's a million numbers. Times 400 pages is 400,000. Please be 400,000 and not 4 million. 400,000 seconds. 400,000 seconds is how many minutes, which is how many hours? 111 hours. Uh-oh. I think my whole thing about if I reach 1 million subscribers, I'll read all of the numbers is a bit of a problem. All right, like I would have to read it, like to be able to do this in like one day. So it's 1 million numbers. I need to, yeah. This is a bit of a problem. Oh, let's check the poll. Okay. Wow, binary tree. Fascinating. Huh. Boy, this is going to show. I really need to stay hydrated for a binary tree. Hypnodox asks, am I right that he wants to do a machine learning algorithm that learns to play a game? Yes. I want to do some demonstrations of reinforcement learning for machine learning algorithms to play simple games like Pong right there in the browser with JavaScript. Anybody who wants to help me with that? Sign right up. Okay. Okay, so yeah. So if anybody has, I love the idea of a 1 million subscriber challenge, and I love the idea of connecting it to this book, but reading this for 5 days straight seems problematic to me. I don't mind stretching myself, like I'm going to do this all day for 8 hours and take some pee breaks and eat some lunch while I'm doing it. That I don't mind. I don't even mind doing it maybe if I could leave and then come back, but I don't want to do anything to jeopardize my health. And I think reading this for 5 days straight would cause that. Reading it for 1 day straight, 24 hours, would cause that. Okay, problematic and boring. Okay, so I'm going to give this 168 votes. That's kind of amazing. I kind of, looks like binary tree is running away with it. So, FlipKid MC bought one of the shirts. So by the way, let me take this moment to let you know that there are Coding Train shirts available. If you go to codingtrain.storeenvy.com. I'm still working on, so you can see, I'm still working on, there's a particular logo that actually people really seem to like, which is a little bit less rainbowy and crazy, which is just the train and Coding Train. So I'm looking to add those as a t-shirt. Some folks requested that. I might remove some of the colors if they're of less interest. And then there are also, if you click down here, there are also mugs. So this is a way that you can support the Coding Train by buying some Coding Train merchandise if you are so interested. Also, I mentioned I have, if you go to thecodingtrain.com, this is where I can see myself live right now. That's me. Oh, this bow tie is really not straight. You can subscribe. Anything you could do to tell people to subscribe, become a patron, all that kind of stuff is appreciated. Hypnotics asked a follow-up question about this reinforcement learning. So do you use the actual variables of the game and feed them into the algorithm, or do you use a screen cap and feed that into it? So both strategies are possible. I would actually like to do the Google's DeepMind and this Universe AI. I don't know if a lot of these standard research projects have done it just with raw pixels, which is a really generic, feature-free way of like the bot, the AI system knows nothing. It just reads the pixels, makes decisions, reads the new pixels, makes decisions, and it gets a reward or not a reward based on how well it's doing. So I think that's an interesting way of doing it. Okay, yes, here we go. Zoom, 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 zoom. Okay. So I mentioned that. Let's check on the poll. Here it is. I think it's binary tree, everybody. I see no way around it. It's interesting to me that one of the things that I struggle with is that I think the YouTube audience, and there's nothing wrong with this, but skews more towards computer science, traditional computer science algorithms and interests. And I am really, one of my hopes and desires is to bring new audiences into programming through other fields in a way like, to sketch and make something and try something out, you don't need to have learned and memorized and be able to, on a test, write all these algorithms. It's often interesting to me that to see what people are interested in. So anyway, but the binary tree is a great thing to do, and we're going to do it in JavaScript. Okay, and this isn't going to have anything to do with P5, because I don't think I'm going to visualize this. I think I'm just going to build the data structures and make it as a challenge or assignment to visualize it, because this is actually lesson 1 for my class on machine learning. How about that? So should this be a coding challenge? Binary tree code? I guess it is. I guess everything is a coding challenge unless I've already made the example and I'm just explaining it, right? Or is this a tutorial and goes in the playlist? So hard to say. Let's make it a coding challenge. Okay. Can we see brackets today? Right. Chris Jordan writes, how can you make binary tree visually appealing? And so this is exactly the right approach. Okay. Thank you, everybody. Here we go. This is. Oh my God! It's almost 5 o'clock. Okay. I'm just in my own little world typing away here. Okay, poll length. You only get 10 minutes for this poll, 0 days. Here we go. Okay, place your bets, everybody. Here we go, binary tree. I'm not going to use a timer. I was trying to save Mathieu some work by not allowing myself to edit. Sat here watching with my 14-year-old. Not sure they get it, but they're laughing. That's the greatest thing for me to hear. Okay, 2 hours. Okay, I'm going to press some buttons on these cameras. Okay. I am going to erase this here. And here we go. Ye of little faith. I'm going to guess 30 minutes. 45 minutes. It's not going to be more than an hour. I guarantee. Please no timer. There will not be a timer. Oh, that Pong video. I just had this desire. I was like, these videos that have like really caught on, and I've got all this like, let's make another one of those. Pong. It was so simple. I'll do a timer. People will love it. The masses will cheer. They will lift me to the top of the mountain. Carry me unto the river. I don't know what I'm talking about. Okay. We're going to do this in JavaScript. How about that, folks? Okay, so hold on. I'm going to call this binary tree. And I do need to explain a binary tree. Oh, Adam. Oh, Adam, you came and you bought me a turkey. But I wasn't afraid. Oh, Adam, code editor. My other song that I like to sing is delete, delete, I'm so in love with you. Delete, delete, oh, with your eyes so blue. Delete, delete. Okay, we don't need digging. There will be no ding.mp3 in the binary tree. We don't even really need p5. We don't need this paragraph element. But, and then I need to go to here. And I'm going to go to run my little server. Please, no timer. Oh, Mandy. What is this? What is that song? Okay, so let's just go here. Function setup, no canvas, console.log, tree. There we go. Okay, we are ready for binary tree. Okay, binary tree. All right. And is binary tree actually in this book? Binary search is. So I think it's just, but I think I will mention this book. Yeah, I'll mention this book when I will. Why not? Okay, how's everybody doing? Don't have to use semicolons in JavaScript. I cannot live without semicolons. I know you don't have to use them, but I need semicolons, please. I have to have them. It looks wrong. It makes me very uncomfortable without the semicolons. Did I turn my sound off again? I need my semicolons, semicolons me. Semicolon, 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 semicolon me. Okay, all right. Here we go. Do I have any codes for buying merchandise on Store Envy? Let me just remind you, if you were wondering again, what's this guy on? I'll have what he's having. This one, Yogi Ginger Tea, supports digestion, which is very important for me. Okay, now, here we go. Self-balancing tree, that's not happening today, but it's a great suggestion. But I'll definitely mention it. Okay, let's get started. Okay. Okay. He is getting weird if he streams too long. I'm glad to know that maybe I wasn't so weird at the beginning. Hello, welcome to this is a coding challenge. This is a coding challenge. The coding challenge today, right now, is a binary tree. Okay, that's what I'm doing. It's actually kind of an interesting thing. So first of all, I've been reading this book recently. I just finished it called Grokking Algorithms. It's great by I'll put a link to it it's by Aditya Bhargava. I'm sorry I pronounced that wrong. I'll put a link to it in the this video's description. And it's been refreshing my brain about all these algorithms that I may have once learned and then never really bothered to use again, even though they are vital and important. But what I really want to ask in this series, because I'm going to have a bunch more related to this sort of similar topic, is what kind of creative outcomes can you have with this? So I'm going to come at this from a very no point of view approach. Let's just look at the literal binary tree algorithm. Let's make a version of it. I'm actually not going to include any visuals. I'm just going to show you the results in the console. And I'm going to ask you, the viewer, to make some type of visual out of it or to do something more interesting with it. So maybe when I get to the end, I'll have some ideas for you because I don't have them right now. So look, I have all these pictures of binary trees behind me. And let's go over here to the whiteboard and let's make a diagram. So why would you need a binary tree, first of all? And actually, this is the example that's in this book, so I'm going to borrow it. Pretend this was a phone book. It's not a phone book. But it's a big book. It's a book of random numbers. That's another story for another time. And let's say I wanted to find where I am in this book. By the way, do you even know what a phone book is? I just said, pretend this is a phone book. People of the future, aliens of the future. A phone book is a book. I'm speaking to you up there, not you. Hold on. People of the future. A phone book is a book with people's names in it and everybody's phone number. Oh my God. A phone number is a sequence of digits that you use to call somebody on a phone. A phone. Let's just, I don't know how far into the future you are. Hopefully you still know what a phone is. Anyway, let's say this book was a list of people. Dictionary, maybe dictionary. It's a dictionary. A dictionary is a book, I don't know, list of words. And I want to look up the word rainbow or train. Pick your word. One way I could do is I could go to the first page, and I could say, oh, apple. And I could look at every single word on the first page, it's not there. And I could look at every single word on the next page, it's not there. And I could look at every single word on the next page, it's not there. But I know rainbow is R, which is going to be, somewhere around in 2/3. So I have a sense of where it is. But another way I could look is I could just go straight to the middle. And I could say, is the word that I'm seeing here now, does it come before or after rainbow in the alphabet? If it becomes before, if it becomes before, then I'm going to go halfway towards the end. Then I can go halfway back, then I can go halfway again. So I could keep finding by dividing all the words up in half. I play this with my kids all the time. Let's guess a number between 0 and 1,000, and I'll always guess 500. And they say, well, it's too small, so I'll guess 750. Well, that's too big, so I'll guess, whatever's in between those two. 625? I don't know. 675? Oh my God, I can't do the math. So the point is, a binary tree is a data structure that allows you to move through sorted data by dividing it in half. Now, there's a lot more to the efficiency of the binary tree beyond that, but let's just start by designing one and come back to some of these questions later. So first of all, what do I mean by data structure? Here's a data structure. var x equals 10. My data structure is a single number. Here's another data structure. var nums equals 10, 11, 12. This is an array. It's a list of information. There are, I can have an object in JavaScript, which is a mapping of keys and values. Favorite color, whatever, purple. So these are different kinds of data structures that you're familiar with. It's a structure where you store data. And we could get fancy about it. There's things like linked lists, which each object, each thing points to the next thing. So you can only get to it from the beginning by going through all of them. And boy, I should make some other videos about all these things. And there's stacks and queues and all this stuff. A binary tree is a data structure that works like this. There is this idea of a node. This is a node, and I'm going to call this node the root of the tree. And it has maybe a child, two children, two children nodes, one the left one and one the right one. It's a binary tree because each node can only have two connections, two children. Other kinds of trees can have all sorts of variable amounts. Here, here, here. So it looks like this. Now, this is the way the data is organized. But I said the data is sorted. What do you mean? That doesn't look very sorted. I mean, I could imagine this being sorted. Well, strangely enough, it's sorted in quite a remarkable way. And the way that you build a tree is by adding nodes to it one at a time. So let's use numbers. Somebody shout out a number. There's nobody around. I can't get anybody to give me a number. Oh well, I'll have to think of one. There's a chat going on, but I can't see that far from here. So let's say I have the number 10. I'm going to add these numbers: 10, 5, 15, 7, 2, 9, 31. This is a list of numbers that I just sort of thought of in my head that I'm going to add. So I'm going to add to the tree first 10. So 10, the tree is empty, so the root node gets the number 10. Now I want to add 5 into this tree. And right now the root node has 2 empty spots. As soon as I make a node, it gets 2 empty spots. Now 5 is coming in here. And I believe if 5 is less than, it should go to the left. And if it's greater than, it should go to the right. Boy, I hope I'm doing this correctly. There's, obviously it could work either way, but there's a standard. So 5 is less than 10, so it's going to go here. And now this has a left and a right with nothing. 15. 15 is more than 10. It's going to go over here. And this has a left and a right. 7. 7 is less than 10, so it goes over here. Oh, 5, it's greater than 5, so it goes over here. And now this has a left and a right. 2. 2 is less than 10, 2 is less than 5, 2 goes over here. I can't keep track of the way that I'm using dotted lines or not. So this, okay, we got to get through the whole thing. 9. 9 is less than 10, it's greater than 5, it's greater than 7. 9 goes down here. 31. 31 is greater than 10, 31 is greater than 15, so 31 goes here. So actually, I don't know, just sort of erase these. These are all the empty spots. So this is the tree. So how is this sorted? Let me tell you something. This is most certainly sorted. It's sorted because if I go all the way to the left, watch this. Let's go to the left, 5. Let's go to the left, 2. Let's go to the left. Oh, nothing left. Let's put out 2. Now let's go back. Okay, 5. Oh, now let's try, sorry, go to the left, go back. Now we try to go to the right. Sorry, go to the right. Nope. So let's come back, go up here, 5. Now can we go to the right? Yes, 7. Go to the right, 9. Actually, sorry, 7. We should try to go to the left. But we weren't able to go to the left. So we came back, 7. And now we go to the, This is so hard. Let me do this again. I don't know if I should edit this and come back. But the algorithm of how we traverse this tree is we want to visit every node. Visit a node. And when we do that, we want to go to the left, which means that means visit the node to the left. So we're going to implement a recursive algorithm, a recursive function, a function that references itself. Visit a node, go to the, and so I should say, start with the root and then visit left. So we keep visiting left all the way as far as we can. Eventually we can't visit left anymore. So then we might say, print, I'm just going to say print the value. So we come up and print the value 2. What's the next thing we do is we visit the right. So now we go down here. Oh, there's nothing there. So we come up here, and then these are finishing. Where were we here? Now we've finished visiting 5, so now we print out the value 5, and then we visit right, 7. What do we do when we visit 7? We then go to the left. nothing there. So we come back and print out 7. Then we visit the right. Then we go to the left, nothing there, print out 9. Go to the right, nothing there. Back, back, back. Here. Then we print out 10. Then we go to the right and we try to go left, nothing there, 15. Then we go to the right, nothing there, 31, and we're done. So this tree, magically, the way that the things are added to the tree end up in sorted order, because what we're doing is we're basically saying, I want to look here. This is how it ties back to that phone book example. Oh my goodness, can't believe I missed this. If I want to find the number 9, right? Let me find the number 9 somewhere. Like I want to find this name in the phone book, because the number 9 might be associated with some actual important piece of information we need. The 9 just being like a key. I can say, is 9 less than or greater than 10? And if this tree is balanced nicely, meaning there's the same numbers on the left and the right, I now have eliminated. I don't have to search through half of the data. Whereas if I have an array and I need to try to look through the array to find something in an unordered array, I have to check every single option. So this is the structure. How do we program this? This is the next step. Okay. Let me pause for a second. Okay, somebody is spamming the chat. Thank you for removing that. How's this going? Anybody have any questions they want to ask? Does that make sense? Do you think I should make this 2 parts or just keep going in the same video? How long was that about? Slow clap. What was the book I was talking about again? Where did I put that book? It's, do I forget? Keep going. Okay, I'm just going to keep going. It was this book. Okay, same video. I'm going to keep going. Okay, I'm actually going to give Mathieu some editing for today. Okay, so back over here we can see all of these nice visualizations of trees. Maybe I'll try to add a little visual something just so you can get, would you get started with visualizing it? But hopefully that gives you an idea of what it could be useful for. Talk about that. Okay, so now let's start to program this. So what do I need? How would I even get started programming this? Well, think about this. I think I'm definitely going to need a node object. So I'm going to write a constructor function called node, and it's going to have a left and a right. And I'm going to set those equal to null, just to sort of explicitly say when I make a node, and the node should have some kind of value or label. I guess I'll just use numbers. Maybe I should use text. I don't know what's better. But let's call it a label. So I'm going to make, it's like the sort of data at that node. I'll call it value. Right? So when you make a node, it has a value and it has a left and a right, which have nothing connected so far. Let's make a tree object too. I don't know if the tree is really going to need anything, but a tree is going to have a root node. And then also, so that when the tree starts, this dot root equals null. So one of the things that's interesting about this data structure is I only ever need a reference to the root. If I have a reference to the root, by moving throughout the tree, I can find any element. Okay, so what happens if 2 numbers are equal? We'll get to that. That's a great question. Okay, so what do I want to do? I need a function. I'm going to use prototype to attach functions. So I want the tree object to have a function called add node, and it gets a node as the argument. And the first thing I'll do is just say if this dot root is equal to null, then this dot root equals n. Great. So then let's say node n equals a new node. Let's use numbers for right now because I think that'll be a little easier to see. 5. And let's make a global variable, just tree. This should probably be called binary tree, but tree equals a new tree. Then I have this node and tree.add node n. Okay, So, and then let me just say console.log tree. So let's see. So this should be, so by the way, I'm using P5 here, but there's actually nothing about this that I'm using. There's nothing here that I'm using P5 other than the setup function. I have no canvas in there, so it doesn't draw a canvas, but I'm actually going to probably out. And I have an error, someone just pointed out. If this dot root equals null, if I want to test if it's null, I need a double equals. And if I really, really, really want to test, I could use triple equals. Someday I just want to make a video only about double equals versus triple equals. Just such a funny little concept. Maybe I should do that before I leave today. Okay. There we go. So now let's run this program. Where am I here? Uh-oh, I have an error. Sketch.js line 1. Oh my goodness. I've been programming in too much Java today. This should be var tree, right? I don't need to give it a type. And this should be var n. Boy, I was programming in Java earlier today. You can tell, right? Okay, oops, wrong thing. Console.log, not capital tree, that particular object. There we go. So we can see the tree has a root and it has a node. The root is a node with a left and right being null. Perfect. Okay. Here we go. So we're in pretty good shape. Now what happens if I create another node? And you know what, you're right, I don't really need this variable here. I can just do this. I don't need a separate variable. I can just say add a new node. I could also, if I really wanted to, what if I just to make things a little simpler, I'm going to say add a value 5. And I'm going to have this function create a node from it. And so this is really the same sort of thing. But this is just a little simpler now because I can have that function take care of that. OK, so what happens now if I say add value 3? Now, first of all, was I right that things that are less than go to the left? Let's go back to the browser, that binary tree. Yeah, it looks like these examples. Uh-oh. Whoa, I don't know what this is. Oh boy, I don't know what's going on with these binary trees. What? Yeah, this looks right. So less than goes to the left. Some of these images are doing something slightly different than what I'm doing. Should not rely on Google image search. Okay, let's go back to my code. So let's say I want to add node. Okay, so I have another error. This needs to be add. I changed this to add value. Maybe I should just call it add, but whatever. So now what do I do? If root is null, it should be the root is that node. So what if root is not null? So what I need to do is say this dot root add value. So really what I should do, this is interesting. This dot root add value. Okay. Listen to this. This is crazy. So I actually, I'm losing my mind here. Okay. Otherwise, here's what I want to do. Otherwise, I got it. This dot root add node. Sorry. Dot add node n. So okay, what am I doing here? So what I'm doing is I want to say if the root is empty, just set it equal. But what is this function? This dot root add node. This means I need a function as part of the node that knows how to add something to itself. Oh, this is great. Right? So I need a node function, node.prototype.add node equals function n. So that's the node that's coming in. Now, what happens if I'm a node and this comes in? Well, I want to compare the value of n. If n's value is less than my value, then this dot left equals that node, right? It should be, so if I'm adding it to myself, if it's less, it should go there. Otherwise, this dot right equals n. But this isn't correct. This is a nice idea, right? And it will work for just the root, because when these two things are empty, it will get added here. But what if it goes to add to the left, but there's something already there? Well, it needs to check against that one, and in that one it should then go to the left. And it should check against that one, and then maybe that one should go to the right. So here's where I need recursion. What I actually want to do is say this dot left add node n, or this dot right add node n, right? Because I want to just say keep going. But what if this dot left is null? So if this, there's probably a more elegant way to write this. If this dot left is null, then it should be that value. Otherwise, keep going. Same thing here. If, if this dot, I see a lot of chat messages telling me I'm doing something wrong, so I'm sure I'll discover that in a second. If this dot right equals null, this dot right equals n, else add node. Line 17. Var n. Okay, big deal. That was all it was. Because I keep writing node. Okay, so I don't think I have anything. Hopefully, I don't have anything majorly wrong. Now, I'm sure there's a way we could write this. We could refactor this to be a little nicer. But it is saying exactly what it's doing, right? If this value should go to the left, if the left is empty, perfect. Put it there. Otherwise, recursively go and call that function again. Otherwise, if it's go to the right. Now, here's the thing. If it's equal, I kind of want to do nothing right now. So I think what I'm going to do with equal, if the node is equal, it just shouldn't go anywhere. And so in that case, I can say else if n dot value is greater than this dot value. So actually, in the case of those two values being equal, nothing will happen. So an equal value won't get added to the tree. Okay, so let's take a look at this. Okay, let's run this. Let's run this. So the tree has a root which has a value of 5, and to the left of it has the value of 3. Boy, this is a really awkward way to look at it. So we're definitely going to want to visualize this in some way to see if what we're doing makes sense, but we can see that this is correct. Now, if I were to then say add the value, it's weird that I console logged it later and it was there. Add the value 7. Let's try that. The tree has a root, and the root has, if I zoom into this, the root's value is 5, the left's value is 3, and the right's value is 7. That's exactly right. Let's just try one more thing. Let's just, let's add 6. That's a little bit tricky, right? But it should be 6 should go to the right of 5, to the left of 7. So let me refresh this again. The tree has a value of, the root has a value of 5. Left is, has a value of 3, sorry. Right has a value of 7. And to the left of that has a value of 6. So this is no way to understand or see. This is like, I'm kind of used to this weird JavaScript console, but the tree is there, right? And only thing I need to know is the root. So remember how I said, okay, well, what if I want to then look at all of the values? Or what if I want to search for, the whole thing was this is like a binary search tree. The idea is we're storing all this information in this tree. I could search for something in it. So how do I traverse the tree? How do I traverse the tree? So let's just look at how we would traverse the entire tree. And this is exactly it. I want to start by visiting the root. And when I visit the root, I visit the left. Then I print out its value and visit the right. But that's done recursively. So visiting the left means visit this left, means visit its left until there's no left, then come back, then print out the value, then visit the right, etc. So this algorithm that we worked out, it's very hard to hold this into your head. So recursion is new to you. I think I have a video where I go over it and look at like factorial, in fact, the math, drawing some like recursive trees and fractal patterns. You might look for some of those videos. But this is a tricky thing to get. So let's create a function now that's part of the tree. Prototype dot, I'll call it traverse. Since this will be edited, Matthew can edit that. I'll call it traverse, and it is a function that says root dot visit. Wait, is this right? So what I want to do is first visit the root node. Okay. And then in the node, and you know what I need to do now? I need to make some separate files. I'm going to make a file called tree.js, and I'm going to make a file called node.js. Oh boy, is that a problem? Node.js. So if I go to Sketch, I just want to be able to pull this code out and look at it on its own. So tree just has these three functions now: the add value, the traverse, and the tree. So the tree is just really a wrapper for the root. That's all it kind of does. The node is where all the sort of guts of the algorithm is. So I want to take all this node stuff and put it here in this file. And here we go. So now all I have is so far is the constructor to create the node, which has a value and a null left and right, and then this add node function, which recursively figures out where to keep going through more and more nodes to where to add it. Now what I want to add is a function called visit. And what does it mean to visit? This.left.visit, this.right.visit. So I always want to go to the left first because I want the lower values first, so that was definitely right. And then I want to visit to the right. But in between, if I go all the way down to the left, if I want to actually do something, I want to process the value or check what it is, here's where I would say console.log this.value. So here's the problem is though, I don't want to say this.left.visit if it's null. So only if this.left is not equal to null. And I know I could, in JavaScript, I could just say as long as this.left exists, but just in case, it could have the value of 0, which is going to cause me a problem. So I'm gonna stick with checking to make sure it's null. And if this.right does not equal to null, this.right.visit. Okay. Look at this. So simple, beautiful, elegant. I love this kind of stuff. Line 7, I have something wrong in line 7. Node.prototype. Thank you. I love having a chat that debugs this stuff. Okay, so here we go. I think I just sort of typed this from scratch. Could this possibly really work? So let's now, let's go here and see if in the sketch, I'm going to now say tree.traverse, and I should just see all the values in sorted order. Okay, tree is not defined. Oh, of course. I always do this. I forgot to add a reference to these two new files. I just invented a whole new JavaScript library called node.js. Not really, tree.js. There's a whole big server-side JavaScript programming framework called Node, so I feel like it may be a little bit weird that I called my file node.js, but we'll live. Okay, root is not defined. This dot's on. I forgot this dot, clearly. Did I forget it anywhere else? I don't think so. Let's run this again. There we go. Look at those values. 3, 5, 6, 7. Okay, let's try this in a crazy fun time way. Because hasn't this already been so much fun? Let's say for var I equals 0, I is less than 10, I plus plus. Let's add a random number between 0 and 100. And I'm going to floor it just so it's integers, even though I don't really need to. And I'm going to console log the tree and say tree.traverse. So instead of hard coding the numbers, I'm going to pick random ones. And let's run it. These look sorted. These look sorted. These look sorted. It's great. And let's add 1,000. Yep. That happened pretty quickly. So, I mean, we'd have to. Now, here's the thing. Let's go back to just doing this with 10. Let's look at the actual tree. The root has a node to the left, which is 68. No, the root is 89. To the left is 68. To the right is 93. See, again, this is no way to look at it. So we're done with the binary tree. I didn't actually add a function that is that involves searching the tree, which I probably should. That would kind of make sense. So we could search. So we could add that. Let's add that. Let's add a function that searches the tree. And it's going to be very similar to traverse. So we're going to say tree.prototype.search equals function. I'm going to search for a value. And we're actually just going to do the exact same thing. Oh, sort of. We're going to say this.root.search for val. So again, the tree object is just a wrapper for the root. And we're going to say search the root. So now this visit function is going to be very useful because we're essentially doing the same thing. But what we're first doing is we're first saying, does this.value equal val? Right? Then I want to say console log found plus val. And then otherwise if this.value is less than, if val is less than this.value, then and this.left is not equal to null, then I want to go and search for that value here. And then I'm going to do the same exact thing for the right. And I'm going to search for the value to the right. So this is how I could just say, hey, is the root the value? No, but I'm less than it. So just let's look at everything to the left. So I don't need to, I'm not traversing the whole tree. I only need to go the one direction that I need to go. So insert one direction music right now. Okay, so let's do this. Let's see if this works. So this is what's in the tree right now. All these numbers. So if I say tree.search 53, this .root search is not a function. What did I do wrong? I called it visit again. This should be search. Let's do this again. So I want to say tree.search, let's look for 61. Found 61. Can you guys see this? Refresh this again. Well, you can't see at the bottom there because it's cut off. So let's do this. Sorry, hold on. So let's do a tree.search. Let's look for something that's not there. So 9 is not there. Undefined. So that's pretty good. I probably should have something where, that's fine. I might want to explicitly somewhere say at the end return undefined or return not found. But I can basically say here now in my, wherever I, you know what? I should just return. So that's what I should do. Sorry. Right when I found it, that's what I should do to make more sense. Right here, I should say return, I might as well return the node. Return this. So I found it at this node, so I'm going to return the node. And then at the end, I believe if I just say return, null. So if it never finds it, eventually it's going to recursively percolate through all these functions to get to the end and return null. I think that's right. So let's do this again. So now let's say tree.search for 20, which I know is in there somewhere. And, I got undefined. You know what? This is not the right place for this. Because, right? Because it could be, because it's equal? No. Vertical bow tie mode. Wait. Let me take this out for a second. I have to think about that. Tree.search 4. Undefined. What's wrong here? What did I miss? Return this. Console.log found val. Oh. Whoa. This should say var found. I don't know why I didn't have this in. I didn't add the part. I'm really sorry, everybody. My brain must have just melted. Var found equals this. So if found is not console.log, found, and then I could put that object out. Otherwise, console.log not found. I don't know why I missed that. So we're searching. Okay. So now I should say tree.search 10. Found 10, not found. So why does that happen? Why does that? Oh no, it didn't. It found it, but it said not found. What am I? Oh, my returns is all. My return is all messed up. Let's think about this. Boy, this is hard. Search, found. Oh no, I'm in the wrong place. Oh, I'm in the wrong place. This is where I just haven't really thought about what I'm doing. It helps to think about what you're doing. What am I doing? I want the tree. This is the function I'm calling. I want this function to return something. It's printing out the right thing. The whole point of this is not to print something out, but to return the thing that's found. Return found. That's all I need to do. Forget about all this. I want to return found because I want to see it in the console. Somewhere else I might call it. So I just kind of got confused because I'm typing everything into the console, which is a little bit confusing. So let's run this again and say tree.search 19. And hold on. Did I not save everything? I don't want this anymore because it's too confusing. So this should return this. And it returns it to here. And then this should return it. Found 10, not found. Let me try this again. Why am I not getting anything? Oh boy, what did I miss? This was going so well. Found, not found. Okay. No wonder his return self. Yeah, no, return this. If I find this node, otherwise keep searching. I think that it's clearly finding it, but does something get returned beforehand? Do I need to console log found? I just want to see that. Okay. What am I missing? This is going to have to get edited out here. So it finds it, but then it returns. Where does it? Okay, hold on. Let's just try this for a second. You need return this dot. Oh. Thank you, Alka. Thank you, fake account. Yes, thank you, everybody. I see it now. So, I don't know, Mathieu, maybe you can splice this back in there at some point. Okay. Of course, the problem is if I want to return a value, one of the nice things about this visit thing is I was just going through everything. I wasn't worrying about returning a value, so I would just call the next function. But if I I need to return the results of the recursive calls. So I need this return, and I need this return. So this should really fix it. So I'm going to refresh this. Now I'm going to say tree.search 12. And now I've got 12, but as I changed it to, but I want to, let's return a reference to the full object, doesn't really matter, but tree.search 5. And we can see I got the node now which has the value 5. I know this laptop is kind of covering it. So okay, so that's how you search the tree. And if, by the way, I search for something that's not in there, I'm going to get undefined. However, I can put this back in just to be sure, and I can get null. So if what I want to do is, now actually here I could say, tree.search, 10. Let's just see if this tree has 10 in it. And I could say now if result equals null, console.log not found, else console.log, result. So now I'm going to run this, and 10 is not in there, 10 is not in there, 10 is not in there. How likely is it it's going to put 10 in there? Oh, it had one that found 10. So, about 1 out of every 10 times there, I can't stop hitting refresh. Stop, find it, find it, find it, find it, please, find it. Oh, come on. Oh, no, refresh again. What's wrong with me? Okay, you guys get the point. Okay, so this is a binary tree. Woo! Hopefully what you've seen now, just to summarize, I think I'm going to, in a separate video, make a part 2 where I just add some visuals to it. But that's what I want you to be thinking about. Well, why would you? This is an important data structure that you can use to store information for binary search, for sorting, for dictionary of words. There's so many possibilities. But the key thing, whoops. But the key thing is what kind of creative outcomes could you have here? Could you create some type of game which involves a binary tree and you have to add things and find things? There's the sort of Plinko thing I made before. Could you make a binary tree where added some physics to it? Just visualizing it. Is there something beautiful in the way that the binary tree, you traverse the binary tree recursively? Could you do some kind of nice animation? I think there might be some unique possibilities there. So I'm not very good at this kind of stuff. Any of it really, but especially the visual stuff. But in the next video, I'm going to at least try to draw some of the tree so we can see how it looks if we draw the sort of basic elements. Okay, I'll see you there. Goodbye. Okay. Okay. Boy, this is somehow like a 3-hour and 20-minute live stream. It's like 5:30. What is going on? I have a problem. This is the last thing I'm going to do. How many times have I said that? But this really is the last thing I'm going to do. And I'll be back next Friday. Then I have to prepare an entire new course on machine learning this weekend while going to a lot of different children's activities and classes. Please help. Anyone who wants to contribute to my GitHub repository, please. Okay. Let's do the visual thing real quick. So I'm not going to include the search. Oh, let me make a separate version of this. Whoops. Oh my goodness. Let's open this in Atom. I've run out of steam. I'm not staying hydrated, I guess. Let's close this other stuff. The timer. And okay. Let's figure this out. Oh, I'm in the right place, sorry. Okay, I don't need this. Don't need this. How'd that poll go? 40%, okay. Sorry, I don't need any of this stuff. Okay. Okay. Okay, here I am back. I did a video about a binary search tree. I don't know how well I did, but I tried my best. And now I'm going to definitely not do such a good job, but I'm going to try to show you some steps on how you might think about visualizing the tree, and I'm kind of going to not do it. I've said this like a bunch of times, but I'm going to just do it in a very simple way, and I'm asking you, the community, those of you with visual talent, with creative ideas, to make a more beautiful animated version of this with some kind of creative possibilities that I can't even think of. So here we go. Let's try to get started here. So first of all, I have the P5JS library, even though I used nothing from P5JS other than setup and no canvas. But now I'm going to say create canvas 600, 400. And I'm going to say background 51. And I'm going to do this. Oh boy, that's a big canvas. OK, that's better. Just zoomed in a little bit. OK. So I'm kind of running out of space here, but let's move this a little bit over. Let's give me a little bit more space here. OK, so this is the canvas. So now, whenever I create a node, let's actually have the node also get an x and a y. And say this.x equals x, and this.y equals y. Then perhaps, well, we could keep the traverse. I could also store all the nodes in an array to iterate through them, but let's not do that. OK, so what do I want to do? Whenever I create a node, where do I do that? Oh, add value. OK. If root equals null, so the root node should be, the x should be width divided by 2. And so I'm not actually using the constructor here. Height divided by 2. So I'm just setting it directly. So I have this option of when I create the node, I could pass it an x and y, or I could just set it. But here I want to set it because I want to make the root node there. Now, let's use this traverse. So the traverse function in the node is right here, which is visit. So instead of, in addition to console logging it, let's just do fill 255 text this.value, this.x, this.y. This is sort of no stroke. So let's just actually draw the text. So let's run this. Look at this. That root node is right there, 68. Now, it's hard for you to see it, but that's fine. And I realized that I want the root to be at the top. So let's make y 16. So we can see the root node is up at the top, 4, which is also happens to be the lowest node. That's just a coincidence. 76 is the root. OK. So now, whenever I add a node, so now when I add a value, if it's root, otherwise I go to this.root add node. So an add node is here. Where is that? Add node. Aha. So this is where I actually set it to be this node's left or this node's right. So if I want to do that, now I could say if it's to the left, its x should be this node's x minus, I don't know, 50. And its y should be this node's y plus 20. I'm just making up stuff. And then when I create the right node, it should be to the right, but its y is still down. So this is like a kind of rudimentary way of doing it, right? The root node gets a location, and then I do the same thing. But whenever I add a node, I look to where I'm adding it, and I just grab that other node's location and move it down and to the left. There's a lot of problems with this, but it'll give us the basic idea. Look at that. So it would be nice now to draw some lines between them. And you can see how, these are on top of each other. So here's where I think I want to stop. Here's where I think I want to stop. Because I'm tired, and I want you, the community, to figure out more interesting solutions. So first of all, what would be a way of, let's see if, can I draw the line even? Can I at least draw the line? Let's try to draw the line. Where do I visit? So visit, how do I know which one I previously, in my traverse, where am I drawing it? I already forgot. Under visit. So this is where I draw it. How do I know where it came from? I don't. So I would have to pass in here. When I visit, I would have to pass in a parent, like where it came from, in order to draw a line from the two different locations. So visit from me, and then in the tree, visit from this dot root. Let's see if that works. Then now I could draw a line which goes from parent.x, parent.y to this dot x, this dot y. And I need, so this would need a stroke. There we go. So you can see this isn't so great. Let's at least draw like, oh, you know what I should do? I should say text align center. And let's also draw a little ellipse. Let's give it like a size. Whoops. What did I do that's wrong here? Ellipse. Ellipse. Wait, what's the error? Undefined text align, spelled text align wrong. Text align. Whoops. No fill. So we can see here, I'm kind of getting started here. This is good. So you can see this is now the tree. But I haven't done such a good job because, you know, these things shouldn't be so, maybe they should be far apart and then closer depending on the level. You know, if this has a lot of numbers in it, like if I were to add 100 numbers to this, like this is a mess. Everything is all overlapping everything else because the nodes next to each other have left and the right. So here's where I'm going to stop. This is giving you an inkling of an idea. So what I'm asking you, the community watching this video, this code will be on GitHub. There'll be a README file there. You can add your versions of it. How can you do a more creative or effective way of visualizing this tree with proper spacing? What might be some algorithm to figure out the proper spacing? You know, you could use physics even. Like what if you used spring forces between all these nodes and some kind of repulsion forces to like have it figure itself out. That's known as a force-directed graph, by the way. I also think it'd be really wonderful to see an animation. So what if you created, here's something you could do. You create a sketch where there's nothing. And you have, every time you press a button, it adds something to the tree and you see it animate to its correct spot. And then you could hit a button called traverse and it animates through the tree in the recursive fashion. So what type of animated ways could you explain trees? So I would love for anybody to do that. Share those projects with me if you want to. This is also a video that's with a course that anyway, just look in the video's description. There'll be links to all the places to look to contribute your stuff. Okay, so, and Alka is making a suggestion, get n items per level and separate them evenly. Yeah, so one thing you could look at is, can you look through the tree to figure out how many items there are per level, and that's how you figure out the spacing. So that's a great clue there. Thank you, Alka, from the chat. All right, I will see all of you another time in another video in another place, not too far in the future, I hope. And have a good, I would say weekend, because right now it's going to be the weekend for me, but who knows, you're watching this like from some bunker in some underground place where it's Tuesday morning or something. Or maybe you're just in a field. I imagine you in a field with flowers around you and the wind blowing. If that's the case, play some Frisbee, frolic, smell the roses. Forget about this binary tree stuff. See you later. Okay, Robin asks, when will the code, okay, what is the site for t-shirts? That's a great question. Codingtrain.storenvy.com. Codingtrain.storenvy.com. That's the site for t-shirts. When will the code be available? So first of all, the code goes in here, rainbow code. It should go here under challenges. And I guess this will be, oops, I'm in the wrong place. Somebody took the Coding Rainbow name on GitHub and there's a fork of it, so I have to go to Coding Train. I always go to the wrong place. This will be, what did I do today? Just Pong, right? So Pong will be 65, I guess. Doesn't really matter. So anybody who wants to type this out and pull request it, but it usually takes me a couple days to get to uploading this. I'm actually kind of behind because I don't have the other inverse kinematics, and these are missing some of the comments and things, but it'll be there. I'll try to do it as quickly as possible. You can always bug me on Twitter @Schiffman. The t-shirts ship internationally. I believe it costs, unfortunately, $10. It's more. So if I click on this and I hit like add to cart and I go to checkout, shipping United States $5. Okay, so let's look. So the T-shirt for let's say what did we ask? Brazil? I think it's really just U.S., Canada, and everywhere else is the price. This is all fulfilled through a company named Printful. I do make a few bucks every time you buy one of these shirts. $10. So unfortunately, the shipping is a bit expensive. And there's also an extra 99-cent fee because Store Envy is like free for me to sign up for, and that goes to Store Envy. And I tried to use Gumroad, but we had Mathieu helped me with this. We had so many problems integrating Printful with Gumroad so that you wouldn't have to have that fee. Anyway, but the good news is if you order multiple shirts, it's not going to charge you $10 per shirt. It's just like $1 more, I think, per shirt once you have the initial shipping. Canada is less if you're in Canada. And I'm not opposed to using another company to print shirts that's a little cheaper. I just, I only have time to do so many things and figure it out. Canada's $8. Okay, a little bit less. Okay, other questions? It's 5:45. I can't believe I somehow did a 3.5-hour live stream. I will be back next week. I have a couple guest tutorials coming hopefully next week, so stay tuned for those. And I'll be back, I hope, next Friday. Things are going to get really busy for me the next 5 or 6, 7 or 8 or 9 weeks until May 15th. So the semester, there's a thesis presentations, there's a show, but I will try to have some extra content. I did a video about the show here at ITP. You can find that if somebody wants to post a link to that from the winter show. So I apologize. I'm almost sure I'm going to miss a week or two in the next couple months, but I'm going to get to hopefully some pretty interesting topics, and hopefully you're going to enjoy them. And thank you for watching. Thank you to everyone who's a supporter on Patreon. Thank you just for watching, just for subscribing, just for writing a nice comment in the chat, or can you get Perlin on the stream? Oh, that's a great idea. I should try. He's here at NYU. That's a great idea. Okay, I will take 1 or 2 last questions. Or I will just read people writing nice comments in the chat. Okay, Juan asked they didn't get an alert for this second live one. I don't know why. A nice comment. How do you make sure there is even distribution on the left and the right? Okay, so there's an algorithm for rebalancing trees, or a balanced tree. It's like what is it called? I forget what it's called. Balanced binary tree. Self-balancing. There's another tree, I'm blanking on it, that has a name. But this is a way that you would rebalance the tree by taking a particular node and kind of moving it up to be the root. AVL, is that what it is? Self-balancing binary search tree. So this is a bit beyond the scope of what I'm prepared or interested to do right now, but I'd certainly be thrilled. Any plans for WebGL integration tutorials? There are so many topics. Boy, would I love to get to them all. That's going to be hard to get to now that I have all this machine learning stuff I want to try to do, but I would love to. Okay. When do I come to Berlin? Oh, I love Berlin. I was there a couple years ago. What is the difference between functional and objective programming? I can't answer that question right now, but there are 2 different approaches, whether sort of objects are your primary thing or functions. Haskell is something I don't know anything about, but that's a language that's entirely functional from what I understand. Okay, everybody. I'm going to go. This has been really fun for me. You've picked me up, you've perked me up. I can't believe that Pong thing is an hour. I don't know what sort of disaster that's going to be when I publish it. I'm going to do a quick intro to that just in case. Where's Pong? So let me go back to Pong for a second. Mathieu, you can use this or not use this based on what you think. I'm going to turn the volume off. Okay. Hello, everybody. You're about to watch a coding challenge where I program Pong from scratch in processing. And I tried to use a timer again and I even made the mistake of using a countdown clock. Because I could do this in 15 minutes because it's so simple. I'm more painfully aware of it. First of all, I get things wrong and I make mistakes and I get confused all the time. So maybe it just takes me a really long time because I know there are other YouTube videos out there that program Pong really quickly. But this video is, I think, about an hour long. And at the beginning, I'm overly ambitious and there's a timer and then the timer ends and I restart it. So I'm just letting you know that what you're about to watch is actually quite a lengthy video, but hopefully it's fun. The whole thing, Pong, is programmed. It's got sound, and it works. It works really, really well, except for all the bugs that are in it, maybe. But if there are any bugs in it, the code that's linked in this description will have all those bugs fixed. So I hope you learned something. I hope you enjoy this. I hope that you make a creative variation of this game of Pong, and eventually I'll come back. Oh, look at it. It bounced in a weird sort of way. Just pretend you didn't see it. Okay, just watch the video. There was still a bug there. I shouldn't have said anything. I'm going to record it again with no bugs. Massive bug. What was that? Oh, I was going to go home. Oh, yeah. The angle is off on the right. Oh, the right paddle is off. Let's fix that. It's got to be... right? This is going to be easy to fix. Remember I had that other sketch where I was testing the angles? So, oh, first of all, I didn't put radians in here. So my test was even wrong. Oh my God. But that's still right. Negative 45 to 45. To 45. It's amazing how that worked correctly by accident. Now 135. Negative 135. Huh. So if it's at the, let's look at that graph again. What did I have to Google? 1 hour late. It's appropriately buggy. What did I have to, oh boy, this Pong thing was such a disaster. What do I have to Google? Again, Pong, paddle angle direction. Image. No, that's not it. Where was it? What was it again? History. Pong segments paddle. Thank you. Pong segments paddle. Whoops. Angle, perhaps? Perhaps I need angle? There we go. So, negative 45 to 45, negative 135 to 135 on the right. Negative, oh, but I wonder if converting it to radians it messes up. That shouldn't be, right? This is the right paddle. That seems right. 135 is down left, yeah. So that seems right. If it's closer to the top. Yeah, see, that looks right. That's right. Oh boy, why did it do that? It's going through angle 0 instead of through 180. So, yeah. I see that. Thank you, TMC. Okay, how do I fix this? Let's go back to my other sketch. Okay. This is good that I'm going to record this intro because let's do map mouse X between 0 and width between negative 35 and 135. Okay, whoops. Background 255. So look at that. Oh, it's totally going the wrong direction. Look at that. No wonder it's all screwed up. Okay. So what it has to be is okay, so it has to go from negative 135 plus 45, plus 90, right? Negative 225 to, hold on, there's an easier way to do this. Let's just check negative 45 to 45 for a second. So that's right, negative 45 to 45. So, or add 180. So what if I said negative, what if I actually did 180 plus 45 to 180 minus 45? That's right. So that's right. So what is that math? 180 plus 45 is 225. To 180 minus 45 is 180 minus 45 is, sorry, 135. Yeah, of course. So that's right. So now this needs to be, 225 radians, 135. So forget about that. So this should be right now. And, oops, it kind of misses the, I really should let it have the radius as a little bit of extra. Okay, this is working. Oh, it's so nice to see it working. See? Yeah. Oh, this is so satisfying. Now, one thing I should really do to fix it, I'm going to just fix this too, is I should give it the radius as buffer. So where is it that it hits left and right? Where that's in the puck. I should also allow it, if y is between, it should be able to y minus r and y plus r, right? I should allow for a little extra of the radius, y minus r and y plus r, something like that, right? Because I should allow it to be a little further off the bottom or a little further off the top because of the radius. Let's play this a little bit. There we go. Look at this. It's so working. Ah, Pong. Oh, I could go to sleep. Okay. All right, everybody. Okay. Okay. Okay, I'm going to finish. I got to do this. Okay, I'm going to, let me download this image. No, it's fine. Hold on. Okay, so let me put Pong here. And let me, okay, so ready? Here we go. Hold on. Oh. No, I'm not doing the hello, I didn't see you there joke. That's the stupidest thing ever. Okay, this is a coding challenge. Never mind. Let's just try. Let's try running Pong again. Hello, everybody. This is Pong, and I just finished a coding challenge where I programmed exactly this. And this is working Pong with very, 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 very few bugs. It probably has some bugs I haven't noticed yet. However, I had a lot of problems making this video. I was so excited. Like, here it is again. I'm going to have the greatest video ever on the internet. It's going to be 10 minutes of making Pong, and everyone will just be able to watch it in 10 minutes and make their own versions of Pong to creative delight of children everywhere. But I failed. First of all, the video is at least an hour long. It's going to be longer now that I'm with this rambling introduction. I had a lot of problems and things I couldn't figure out. And I want to say that there was a major issue. At a certain point later in the video, I used this function to kind of look at how I can map an angle to a direction, because based on where the paddle, where the puck hits the paddle, it should move in a certain direction. And I forgot a couple things. I didn't actually convert to radians when I was doing that test, and the range that I used actually went in the wrong direction. So those things will be wrong in the video. The code, however, that you see linked in this description has the corrected version and is what you see right here. There's some sound. Let me turn that off and I can move. I'm going to play this a little bit more. Right now my left paddle is doing much better than my right paddle, but I made it. I made Pong. I hope you will do creative versions of it, and I'll see you in another video sometime. Enjoy this coding challenge. Okay, add another puck just for fun. Can we watch somewhere the previous live streams? Oh my God, really? Do you really want to? Yes, you can. I will show you. If you go to youtube.com/Schiffman and go to my playlists, is it not one of the ones on this page? Where do I go? Playlists. And somewhere here there should be all playlists. How do I, oh yeah, view 30 more. Load more. There's one that's all the live streams. Oh yeah, live stream archive. So there are 86 of these. Oh my goodness. That is crazy. You can watch all of them. Have fun. Have a good weekend. I don't know, I'm gonna do something special for number 100. We'll see. All right, so I'll see everybody. I've really got to go. Thank you. This is like 3 hours and 45 minutes. I said I wasn't going to do a long one today, but I did. Goodbye. Have a good weekend. Enjoy yourself. I'll be back, I hope, next Friday. I at some point, just always stay tuned. There's going to be some Fridays I'm going to have to miss in the next few weeks, but hopefully it won't be next Friday. Okay? Thanks very much. And yes, I will see you all later. Goodbye. Oh, I usually play my goodbye. I can't.